Yeah, hi guys, welcome to PrepFusion. So, in this video, we are starting vector differential calculus. Okay. So, first of all, we understood the basics of vector calculus. Now, we are going to start the differential calculus. That means we will do the differentiation. When we started calculus in class 11, 12, what we studied? First, we studied differentiation and then we studied integration. So, similarly, first we have studied about the vector, then vector basics of vector calculus we have covered. Now, we are going to study the differentiation and then we will study integration. Okay. Understandable? So we will start that, but before that you answer a simple question, very simple question is there, that some quantities are written and some operation has been applied between them. Dot product, cross product, dot product, cross product. So which of the following operation is valid? And if that operation is valid, then what will be the resultant quantity? The resultant quantity will be a vector or a scalar. So between two vectors, vector A and vector B, can you apply the dot product? Yes, sir. It is completely valid. And what will be the resultant quantity? Resultant quantity will be scalar. Dot product would always result in the scalar quantity, right? It would be nothing but AB cos theta, right? Between two vectors, can you do the cross product? Yes, sir. It is also valid, but the resultant would be a vector only. If you do the cross product, resultant would be a vector only. What will be the answer? Sir, AB sin theta, but it will have a direction as well. Between a vector and a scalar, can you do the dot product? No, this is not valid. Not valid. This is not multiplication, this is the dot product. Can you do a dot product between a vector and a scalar? No, I cannot do. Can you do a cross product between vector and a scalar? Dot product and cross product are done between two vectors only. Dot product, cross product are done between two vectors only. So this is vector, but this is a scalar quantity. This is vector, but this is a scalar quantity. It is also not valid. Now, between a vector and a scalar, can there be multiplication? Multiplication can be there. Yes, surely it is there. So yes, it is valid. And what will be the resultant? Resultant will be 5a cap, which is a vector only. Okay, so first let's write down that resultant would be vector. Resultant would be a vector, right? So it can be written as 5a vector. Okay, or a vector 5, whatever you want to write down. Now you are simply multiplying a vector with b vector. This is the simple multiplication. Are you able to understand this point? Like x multiply with 2, this is how we can write down, no? 2x. So this is a simple multiplication, not valid. Simple multiplication is not valid. Between two vectors, you cannot do a simple multiplication. So what I mean to say is that dot product and cross product could be between two vectors only. Between two vectors only, you can do the dot product and cross product. And if you want to apply any operation between a vector and a scalar, then it would be simple multiplication. Simple multiplication. Understandable? Very simple thing. Sir, why we are studying this? You will understand. Have some patience. Now in mathematics, we have studied the different kind of operators, right? This is a multiplication operator, this is a addition operator, then this is a division, and this is subtraction. Different kind of operators we have seen. Then when we moved to class 11, 12, we started studying about a differentiation operator, which was d by dx, right? We studied about integral operator as well, which was somewhat like this. So similarly, here in vector calculus, in the engineering, we are going to study about an operator. The name of that particular operator is del operator. What is the name? Del operator. Del operator. Del operator. And the best thing about this operator is that it is a vector operator, or I can say it is a vector quantity. It is not a quantity actually, it is an operator. So I would say it is a vector operator. It is a vector operator. D by dx is a quantity? No. It is an operator, no? Right? So similarly, this is a vector operator. What is the definition of this operator? The definition of this operator is the del operator looks somewhat like this. If this sign is made del, that means it is del by del x I cap plus del by del y j cap plus del by del y plus del by del z k cap. This is the definition of this vector. Is that clear to you? This is the definition of a del operator. This is the definition of del operator. Okay, so what do you think? It is a vector quantity, right? It is a vector operator. Although if I am saying in the lecture it is a quantity, then please understand that it is an operator. It is just a slip of tongue if I call it quantity. Okay, so it is a vector operator. So with respect to vector, what you can do? If I am asking you, I am giving you a vector del. Although we will not make it like this, but in your mind you should understand that there is a arrow sign as well. It is a vector. Okay, so if I give you a vector A, let's just say I give you a vector A. Now I ask you how many operations you can do with this particular vector. What you will say? Sir, I can do a dot product with another vector. Sir, I can do a cross product with another vector. Or sir, I can multiply with a scalar. These three operations I can do. Dot product with another vector, cross product with another vector, and multiply with the scalar. So similarly, what he will say? That I can do the dot product with another vector, cross product with another vector, and multiply with the scalar. This is the scalar I am putting by small f. So 3 operations he can do. Is that understandable to you? Since it is a vector quantity, it can do dot product, cross product with another vectors and multiply with the scalar. There you go. So del operator, which is a vector operator, it can do 3 kind of operation: multiplication with the scalar, dot product and cross product. So this is your vector operator, multiplication with the scalar, which is f. So it could be written as del f. What it is known as? Gradient of f. Now someone would say that, sir, can I write down as f del? No, you cannot write down. Del f is the way of writing. Okay. First you will write down the operator, and then you will write down the function. Like d by dx, let us say I am differentiating with respect to 2x. Sorry, I am differentiating with respect to x. I am differentiating 2x with respect to x. So can I write down 2x d by dx? No, you always write down d by dx 2x. No. Understandable? So similarly here as well, the quantity would be written later on. Okay. So it is known as gradient of f. Gradient of f. Gradient of f. Now this f will be a scalar field. Okay, so here I am writing down f x comma y comma z. Multiplication with the scalar, no, but here the field will be there, no. Del x, del y, del z. That means the function will also be a function of x comma y comma z. This will be a function of x comma y comma z. Okay, so gradient of f x comma y comma z. Like f could be 2xy plus 3z. This could be your f. So what you will do, that we will see how you will calculate the gradient, but I am telling you how the f would look like. It would be a scalar. It will not have any I cap, j cap, anything. It will not have any direction. It would be a scalar like this. Okay, so gradient of this f, which is a scalar function. This is a scalar function. Now let me know what will be the resultant quantity. What will be the resultant? What will be the resultant quantity you will be getting? If you multiply vector A with 5, what do you get? What is the resultant quantity? Vector only. So here what is the resultant quantity you will get? Vector only. So here del operator is being multiplied with the function, scalar function f, and the resultant is vector. You don't need to mug up anything. It's just that it is a very simple concept which you will be habitual till the end of this lecture. Okay, till the end of this lecture you will be simply habitual with all these things. So first you understood the meaning of del operator, then you thought that, sir, del operator is a vector operator, then I can apply it with three kind of things, that I can do the dot product with the scale with the vector, I can do the cross product with the vector, and with the scalar I can do the simply multiplication. Now if I do the dot product with the vector, if I do a dot product with the vector, which will also be a function of x comma y comma z. So what this is known as vector field, right? Scalar function, or I can write down in the last lecture we gave it a name of scalar field. So here f vector is a vector field, so I can do the dot product. So what it is known as? It is known as divergence of, ये क्या कर रहा हूँ भाई मैं, ये क्यों लिख रहा हूँ, del dot f. Sorry guys, it is del dot f. So what it is known as? Divergence of f. Divergence of f, which is a vector field, right? So what will be the resultant quantity? What will be the resultant? If you do the dot product, what is the result you will be getting? If you do the dot product between vector and vector, if you do the dot product, a vector dot b vector, the quantity will be scalar, right? The quantity would be scalar. Next is the cross product. Between a vector and another vector, I can do the cross product. So what it is known as? It is known as curl of f. Curl of f. Okay. And what do you think? What will be the resultant? So resultant will be a vector quantity only. Say yes or no. Do you agree to this point? So sir, first we studied about a del operator, which is nothing but del y del x I cap plus del y j cap plus del y del z k cap. Now sir, I can do the 3 operation with scalar, with vector. I can do the operation with scalar function as well, and I can do the operation with the vector function as well. When I do the operation with scalar function, I will simply multiply it. When I do the operation with vector function, I can do the dot product and cross product. Resultant also I know that, sir, vector multiply with the scalar, it will give me a simply vector quantity only. Sir, vector dot product will give me a scalar quantity. Vector cross product will give me a vector quantity. Understandable? Let's go and study gradient, divergence and curl one by one. So first we are studying about divergence. So sir, what does it show? What is the meaning of divergence? Everything we will see, but as of now, first we are only learning the formula. Okay, only simple formula we are learning. What does it show? What is the physical significance? Everything we will see. So first we are talking about that there is a scalar field f which is a function of x comma y comma z. So I need to calculate the gradient of f. This could be written as grad of f, gradient of f. So what is the meaning of this del operator? The meaning of this del operator is, sir, del y del x I cap plus del y j cap plus del y k plus del y del z k cap. That is simply multiply with f. So now what will happen? F is a function of x comma y comma z, so it will be multiplied individually. Like x plus y plus z multiply with f. What will happen? Fx plus fy plus fz. So simply what you are doing, you are simply doing one thing, that you are partially differentiating f with respect to x, then you are adding I cap, partially differentiating f with respect to y, then you are adding j cap, plus partial differentiation of f with respect to z, then you are taking k, then you are adding k cap, and this is known as gradient of f. Gradient of f, since you are doing it on a scalar field. And what is the resultant quantity? It is a vector quantity. Resultant quantity is a vector quantity. Let's not write down vector here. Resultant is a vector quantity only. So this is how you calculate the gradient. So this is the question. You need to calculate the gradient. Then you can calculate the gradient at a particular point. So first we need to calculate the gradient of f. Gradient of f. So how will I represent gradient of f? In this question, can they ask that calculate the divergence of f? You will say, sir, question is wrong. How can I calculate the divergence? Divergence means dot product. And dot product will be done with the vector quantity. Sir, it is a scalar quantity. No, it is a scalar field. So question itself will be wrong. Okay. So what you are supposed to calculate? You are supposed to calculate the gradient. So you are supposed to calculate the gradient of f. So what you will do? Sir, partial differentiation of f with respect to x. Partial differentiation of f. F is complete x square plus yz square. I cap plus partial differentiation of f with respect to y. X square plus yz square j cap. And partial differentiation of f with respect to z. Partial differentiation of f with respect to z k cap. Understandable? What is this? This is your f only. Partial differentiation of f with respect to x I cap. Partial differentiation of f with respect to y j cap. Partial differentiation of f with respect to z k cap. Now you need to do the partial differentiation with respect to x. If you do the partial differentiation with respect to y plus yz square will be constant. Differentiation of x square will become 2x I cap plus partial differentiation of f with respect to y. Z square, x square will be a constant 0. Z square will be a constant. It will come outside. Partial differentiation of y will be 1. So this partial differentiation we have already studied in the calculus. So you should not be having any difficulty here. Now partial differentiation of f with respect to z. So what will happen? X square constant 0. Y will be treated as a constant number. So it will come outside. Partial differentiation of z square will be 2z. So 2yz. 2yz k cap. This is the gradient of f you are getting. Gradient of f you are getting. This is the answer. That's it. Okay. And these kind of questions are directly asked in the GATE examination as well. They will simply give a function and ask the gradient of f. Like this simple question. Although as of now you don't know the meaning of gradient, nothing you know. But still, it is a very straightforward question which could be asked in the GATE examination. Now you need to find it out at a particular point, which is 1, 2, 1, minus 2, 1. So in place of x you will put 1. In place of x you will put 1. In place of z you will put 1. In place of in place of y you will put minus 2. In place of z you will put 1. So answer will be minus 4 k cap. Understandable? Y value is minus 2, z value is 1. So 2 into minus 2 will be minus 4. So this is the gradient at a particular point. Gradient at a particular point, which will be 2 I cap plus j cap minus 4 k cap. Is that understandable to you or not? Okay, well and good. Okay then. So this was about gradient. I hope you know how to calculate the gradient now. What is the simple way of calculating the gradient? That a scalar field will be given and you simply need to calculate the gradient of f. So partial differentiation of f with respect to x I cap, partial differentiation of f with respect to y j cap, partial differentiation of f with respect to z k cap. Get the answer, job done. Let's talk about divergence now. Sir, gradient is completed? No, it is not completed. It will again come back. But as of now, I am just giving you the basic introduction. What is the meaning of gradient? What is the meaning of divergence? And what is the meaning of curl? So basic introduction I am giving you, but again they will come back in detail, we will study. But as of now, only the basic introduction. Okay, so there is a vector field F. Let's write it down as capital F. Okay, small f has been written here. Let's keep it as a small f only. So there is a vector field small f, okay, which is the function of x comma y comma z. That means it could be somewhat like this: x plus y I cap plus 2z j cap plus 3x square z k cap. In that manner it would be there. So what I am saying, I am writing the vector field f as f1. This is your f1, which will be a function of x comma y comma z, right? It will also be a function of, it could be also a function of x comma y comma z. So f1 I cap plus f2, this can also be a function of x comma y comma z. J cap plus f3, this could also be a function of x comma y comma z. K cap, right? So this is your vector field f. What you are supposed to calculate? You are supposed to calculate the divergence of f. So I will write down in short, I will write down as f1 I cap plus f2 j cap plus f3 k cap. I hope you will be able to understand that they are the function of x comma y comma z only. So you are supposed to calculate the divergence of f, dot product between del operator and f, divergence of f. So since it is written in the small f only, so divergence of f, this is how I will calculate. What is the meaning of del operator? So meaning of del operator is del y del x I cap plus del y j cap plus del y plus del y del z k cap. And sir, dot product with f1 I cap plus f2 j cap plus f3 k cap. This is what we are doing. Now x I cap plus y j cap plus z k cap, dot product with some alpha I cap plus beta j cap plus gamma k cap. What is the answer? Sir, I cap quantity will be multiplied x into alpha plus y into beta plus z into gamma. So similar thing will happen here. Del by del x f1, del by del x f1, del by del x f1 plus j cap multiply with j cap, del by del y f2, del by del y f2 plus del by del z f3, del by del z f3. What does that mean? That means you take the function, you take the I cap quantity partially differentiated, you take this quantity partially differentiated with respect to x plus partial differentiation with respect to y plus partial differentiation with respect to z. So if we are supposed to calculate the divergence of f, what you will do? Slowly you will build up the practice, okay? Slowly you will build up the practice of a gradient as well. Just as you see gradient, okay? What I will do first, complete function I will take partial differentiation with respect to x I cap, partial differentiation with respect to y j cap, partial differentiation with respect to z k cap. This is how I will do. And when it comes to divergence, what I will do? Only I cap component I will see partial differentiation with respect to x. What is the answer you will be getting? Partial differentiation with respect to x. X square plus y. What will be the partial differentiation? That will be 2x plus partial differentiation. Then only j cap I will see partial differentiation with respect to y. What is the answer I will get? 2. Then only this one I will see partial differentiation with respect to z. What answer you will get? Sir, 3xy will be common and 2 will come outside. 6xy z. There you go. This will be the answer. Okay. Again, let me tell you that how we wrote down the divergence of f. What was the final result of divergence of f? The final result of divergence of f was take the I cap quantity. What is the I cap quantity? That is f1. So partial differentiation with respect to x, take the I cap quantity, plus partial differentiation with respect to y, take the j cap quantity, plus partial differentiation with respect to z, take the k cap quantity. This will be the final answer you will be getting. Okay, take the I cap quantity, partial differentiation with respect to x, take the j cap quantity, partial differentiation with respect to with respect to y, partial differentiation with respect to z. That's it. At a particular point you are supposed to find out. So, and what is the resultant? What is this resultant? It is a scalar quantity which was expected only. When you do the dot product, what do you get? When you do the dot product, you will get a scalar only, right? So yes, it is a scalar only. And at a particular point you are supposed to find out at which point 1 comma 2 comma minus 1. So put the value x equals to 2. This will be 2 only. And 1 comma 2 comma minus 1. 1 comma 2 comma minus 1. So 2 plus 2 4 minus 12. What is the answer? Minus 8 is the answer. That's it. So gradient of f at a particular point is minus 8. Okay, understandable? Okay then. next we need to talk about curl. Sir, what is the meaning of this -8? Everything we will discuss, don't worry. As of now, our target is only understanding the formula. Then we will see the physical significance for sure. Have some patience. Now we need to understand the formula of curl of f. Again, the vector field is given f1 I cap plus f2 j cap plus f3 k cap. Again, in the same manner, ditto same thing is there. Okay, the same line is there. f1 xyz I cap plus f2 xyz j cap plus f3 xyz k cap. f1 I cap plus f2 j cap plus f3 k cap. Similar thing is there. This time you are supposed to calculate the curl of f. So it will be represented by curl of f. This is the cross product. So how will you do the cross product? Sir, what is the meaning of del operator? So meaning of del operator is del by del x I cap plus del y j cap plus del y plus del y del z k cap cross product with f1 I cap plus f2 j cap plus f3 k cap. Now do you remember how to do the cross product? Absolutely, sir. Cross product we do in this manner. In which manner? We make a determinant. First we write down I cap, j cap, k cap. Then we write down del by del x, del by del y, del by del z. Then I write down f1, f2, f3. Right? And now I solve this determinant. How do I solve it? First I will solve with respect to I cap. With respect to I cap I will solve. So del f by del f3 by del y. Although you don't need to remember the final result, I am just writing it down. Nothing else. Del f3 by del y minus del f2 by del z plus j cap del f3 by del x minus del f1 by del z plus k cap del f2 by del x minus del f1 by del y k cap. This is the answer that you are getting. Curl of f. This is your curl of f. Although you don't need to remember, you need to remember this particular scenario. Okay, you don't need to remember this answer. Right? Understandable? So this is the answer that we are getting. Now let's calculate a curl of f. Function is given, you need to calculate the curl of f. First one is curl of f, which will be I cap, j cap, k cap. Del by del x, del by del y, del by del z. And then you need to write down this function x, y, z, z, and then y square z plus zx. Okay, so what you are getting? I cap, then del by del y, y square z, you are getting del by del y square z plus zx. That means partial differentiation of this quantity with respect to y. So what you will do, this will come to 0, z will become constant, so answer you will be getting 2yz. Then partial differentiation of z with respect to z will be 1 only. Minus j cap. Minus sign comes here. Oh, plus I am writing down. This will be minus. Sorry guys, this was a big blunder. Then we take the next sign to be minus. No, minus j cap. Then del x by del x f3. Del by del z f1. Right? So minus sign would come here. Always remember, in the middle one, always minus sign would come up. Okay, so first this I took, then partial differentiation with respect to y, that would come out to be 2yz, then partial differentiation with respect to z, that will be 1 only. Then I took j cap, partial differentiation with respect to x. So y square z will be constant and z will come out as a constant, so partial differentiation of x will be 1 only, so answer would be z here. Minus partial differentiation with respect to z, so xy will be common, partial differentiation of z will be 1 only. Plus k cap. So partial differentiation of z with respect to x, that will be 0. Minus partial differentiation of partial differentiation of xyz with respect to y. Partial differentiation of xyz with respect to y, that would be xz only. I hope you are understanding what we are doing. Started with here, this line will be gone, I cap partial differentiation of y square z plus zx with respect to y. What will be the answer? Answer will be 2yz. Minus partial differentiation of z with respect to z, answer will be 1. Minus j cap. Then partial differentiation of y square z plus zx with respect to x. What that would be? That would be simply z only. Why is that so? Because this will be constant gone. and z will be common, partial differentiation of x will be 1, so answer will be z here. Then partial differentiation of xyz with respect to z, what will happen? Xy will become common, partial differentiation of z will be 1, so xy, so z minus xy plus k cap, partial differentiation of z with respect to x 0, partial differentiation of xyz with respect to y, what will be the answer? Xz will come common, partial differentiation of y will be 1, so xz, right? Understandable? So this is the answer we are getting. So the final answer is 2yz minus 1 I cap minus z minus xy j cap, z minus xy j cap minus xz k cap, right? This minus xz k cap. This is the final answer you are getting. This is the answer you are getting. Now you need to calculate curl of f at a particular point. Curl of f at a particular point, which is 1, 0, minus 1. So in place of x, you need to put 1, y will be 0. So this will become minus I cap. And next, y will be 0, z minus 1. So it will become plus j cap. And xz would be plus k cap. Okay, let me check back the calculation again. So 1, 0, minus 1. In place of y, I am putting 0. So this term will be gone. This is minus 1 only. So minus I cap. In place of z, I need to put minus 1. So this will become plus j cap, because xy, this will be 0. Xz, 1 into minus 1 will be minus 1 only. Again, minus sign is there. So plus k cap. This is the answer that you are getting. Understandable? So this is how you can calculate curl, divergence and gradient. So gradient, simply take the vector field, partial differentiation with respect to x I cap plus partial differentiation with respect to y j cap plus partial differentiation with respect to z k cap. Divergence, take the I cap, j cap, k cap term aside. For I cap, partial differentiation with respect to x. For j cap, partial differentiation with respect to y. For k cap, partial differentiation with respect to z. Whatever the three terms you get, add all of them. This will be the answer. And then for the curl, you just need to make this a determinant. I cap, j cap, k cap, del x, del y, del x, del y, del y, del y, del z, f1, f2, f3 you will write down, and you will simply calculate the determinant of this particular determinant. Okay, so this particular determinant you will solve and you will get the answer. Now sir, we have understood the formula and everything, but what do they represent? Why we are calculating the gradient? Sir, what is the meaning of d by dxy? That how y is changing with respect to x? So it is representing something, no? What is the meaning of multiplication, sir? 5 being multiplied 3 times. That means 5 is being multiplied 3 times, or 3 is being multiplied 5 times. So every operator represents something. As of now, we have seen the answers, but what do they represent? That we need to understand. So we need to understand the physical significance of gradient, divergence and curl. So one by one we will see, but the important point is that always we will discuss the physical significance at a particular point. Again, let me repeat the statement. The physical significance of divergence, curl or gradient is understood at a particular point. That means at 1, 0, minus 1, you are getting minus I cap plus j cap plus k cap if you are calculating the curl of f. So what does this represent? You will not discuss, sir, what does this represent? No, nothing. What does this particular thing represent? So physical significance of gradient, divergence and curl. If you see all the questions here as well, I asked you to find out the divergence at a particular point. So what does this minus 8 represent? That we will see. What does this represent? Don't know. Is that understandable to you? So physical significance of gradient, divergence and curl we will understand at a particular point. Is that clear to you? So this is the theory that has been written. Physical significance of gradient, divergence and curl. Important note, whenever we discuss the physical significance of gradient, divergence or curl, we are always referring to their values at a particular point in space. Okay, so if the point of consideration is p x comma y comma z, like let's just say 1 0 minus 1, so x naught is 1, y naught is 0, z naught is minus 1. So if your point of consideration is p, then gradient would represent something, divergence would represent something, curl would represent something. Okay, so what they would represent, that we will see, but as of now, first we need to discuss about the gradient. So what does gradient represent? This we will see in the next lecture. This also we will see in the next lecture. In this lecture, now from now onwards, we will discuss the gradient only. Complete gradient we are going to discuss. So what does the gradient represent? Gradient represent that how rapidly a scalar field is changing and in which direction with at the point x naught comma y naught comma z naught. At a particular point, how your scalar field is changing. What is the meaning of scalar field? I gave you the example x plus yz degrees Celsius. So if you are at 1, 1, your temperature is 3 degrees Celsius. If you are at 1, 2, 1, your temperature would become if you are at 1, 1, 1, your temperature is 2 degrees Celsius. If you are at 1, 2, 1, your temperature would become 3 degrees Celsius. So your temperature is changing. It is going from 2 degrees Celsius to 3 degrees Celsius, right? So gradient would represent that how rapidly your temperature would change and in which direction it would change. So it would represent the direction of change, along with that how rapidly it will change. This will be represented by the gradient. So what is the meaning of this? That we will understand with respect to example. But write down the, like, listen to the last line. What is the last line that is saying? The last line is saying that gradient, divergence, curl are local quantities. They describe the behavior of a field in infinitesimally. This word is very difficult to say, so I only say very small. What is the meaning of this infinitesimal? Infinitesimal means very small. So they will talk about the very small change. Are you able to understand this point? All these quantities talks about the small change. Like if I say my dy by dx at x equals to 2 is 4. Okay, that means the change in y with respect to the change in x will be 4. So if you change your dx by 1, then your change in y will be 4. So if you go from x equals to 2 to x equals to 3, let's just say the value of at x equals to 2, the value of y is 4. So at x equals to 3, the value of y will become what? The change will be 4 times. So it will become 8. Is that correct? What I am saying that is correct. What I did was I find out dy by dx at x equals to 2. Let's just say y equals to x square. So if I find out dy by dx, what is the answer I am getting? 2x. So if I find out dy by dx at x equals to 2, what is the answer I am getting? 4. Now what I am saying? The change in x, the change in y with respect to the change in x is 4 at x equals to 2. Is that statement correct? Yes. So someone would say that, sir, if you change your x by 1, that means if you go from 2 to 3, then your y should increase by 4. So at x equals to 2, the value of y was 4. So if you change your x by 1, that means if you go to x equals to 3, your y should change by 4. Your y should increase by 4. So value of y should become 8. But actually at x equals to 3, the value of y will become 9. So sir, how they are giving wrong answer? No, they are not giving wrong answer. I have always said that whenever d is written, no, d or del, they always talk about the small change. This change is very big. No, you are going from x equals to 2 to x equals to 3. It is not an infinitesimal change. Infinitesimal change means very small change. Infinitesimal change means very small change. So they talk about very small change. That means if you go from 2 to 2.00001, if you go from 2 to 0.0001, then the change in y would be by the 4 times. So at x equals to 2, your value of y was 4. So at x equals to 2.001, your value will become 0.004. This is what it would say. So you do the at x equals to at x equals to 2.001. What I mean to say is that when x was 2, your value of y was 4. Now if your x become 2.0001, then your value of y will be roughly around 4.0004 only. You can check it. And this we have seen as well when I started studying about differentiation in our calculus portion. So the change should be small. Are you able to understand this point? The change should not be very large. Change should be small. So they all comment about the small change. So this is the line that has been written. They describe the behavior of a field in an infinitesimal small neighborhood around a specific point, not over the entire field. So they talk at a point, and from that particular point, small change should be there. Now what does this divergence represent? What does this curl represent? That we will see later on. But as of now, we are talking about gradient. So gradient will talk that how rapidly your scalar field will change and in which direction it would change if the change is small. If the change is small. So here important line is if the change is small, which has been written downward. So they will talk about the infinitesimal small change. Okay. Because this is actually a very confusing point when we study about gradient and all. No, if we just talk about the physical significance, like questions you will be able to solve. If I just give the physical significance, no. So from here onwards, we are starting the questions of gradient. So questions you will be able to solve. Look, a lot of questions are there. Without even studying the physical significance, you will be able to solve. But if you don't understand the physical significance, then you will not be able to solve good questions. We need to solve good level of problems, no? Right? So for solving those good level of problems, we need to understand the physical significance of gradient. So that we are going to understand now. So that we will see with respect to an example. So what they are saying, you calculate the gradient of f, then you calculate the gradient of f at a particular point, and then calculate, then comment on its physical significance. So first, function is given x plus 5. What you need to calculate? Gradient of f. What is the meaning of gradient of f? Sir, partial differentiation of partial differentiation of f with respect to x, I cap, partial differentiation of f with respect to y, j cap, partial differentiation of f with respect to z, k cap. So partial differentiation of f with respect to x will give you 1. Partial differentiation of f with respect to y will give you 1, and this will give you 0. So what is the gradient of f you are getting? Which is I cap plus j cap you are getting. I cap plus j cap. It is not having a function of x comma y. It is not a function of x comma y. So even if you calculate it at 1 comma 1, it will be I cap plus j cap. If I ask you gradient of f at 2 comma 1, that will be I cap plus j cap only, because it is simply coming. It is not a function of x comma y. No. If I ask you gradient of f at 99 comma 100, that will also be I cap plus j cap only, right? So gradient of f at 1 comma 1, gradient of f at 1 comma 1, that will be I cap plus j cap only, right? Now, is it a vector quantity? Yes, sir. Is it a vector quantity? Yes, sir. So since it is a vector quantity, what will happen? It will have a magnitude as well, and it will have a direction as well. Both it will have. So what do you think? What is the magnitude? Magnitude is under root 2. And what is the direction? Direction is nothing but I cap plus j cap divided by under root 2, right? Direction you can find out, no? I cap plus j cap divided by under root 1 square plus 1 square, that will be divided by under root 2. And what is the magnitude? Magnitude is under root 1 square plus 1 square, that is under root 2 only. So gradient of f at 1 comma 1 will be equals to magnitude is under root 2 and direction is I cap plus j cap divided by under root 2. So this is your gradient of f at 1 comma 1. Magnitude under root 2 and this is the direction. Now what does it represent? Let's check that out. So let's make a graph between x and y. Between x and y we are making a graph this time. This is your x, this is your y. Let's just say it is temperature only. Let's just say this field is temperature. F is x plus y degree Celsius. This field is nothing but this is representing the temperature only. So if I am at 1 comma 1 point, if I am at 1 comma 1, let's just say this is your x equals to 1 and this is your y equals to 1. So if I am at 1 comma 1, what is my temperature? My temperature is 2 degrees Celsius. 2 degrees Celsius. Now I am standing at this point. And at this point I calculated the gradient. The gradient is coming out to be I cap plus j cap divided by under root 2 multiplied by under root 2. So what is the direction of gradient? The direction of gradient is I cap plus j cap divided by under root 2. So what this gradient is saying? You are at 1 comma 1 point, you got the temperature to be 2 degrees Celsius. Now you are standing at this point and gradient is saying that my direction is I cap plus j cap divided by under root 2. So gradient is saying that if you move in the direction of I cap plus j cap divided by under root 2, you need to move in the direction of I cap plus j cap divided by under root 2. Do you know what is the direction? I hope you know what is the direction of I cap plus j cap divided by under root 2. Here you need to go for 1 by under root 2 and here you need to go for 1 by under root 2. That means you need to move in this direction making an angle of 45 degree. Is that understandable to you? In x you move 1 by under root 2, in y you move 1 by under root 2. So what they are saying is that you move in the direction of I cap plus j cap divided by under root 2. That means you move making an angle of 45 degree with x axis. And let's just say you have moved for 1 unit. Let's just say you have moved for 1 unit making an angle of 45 degree. Making an angle of 45 degree with x axis, you have moved for 1 unit. You have moved for 1 unit. So you will reach at this point. This length is 1 unit. You have moved for 1 unit. So where you will reach? You will reach at this particular point. So how much you have moved? You have moved 1 by under root 2 here and 1 by under root 2 in y direction. You are at 1 comma 1, your temperature was 2 degrees Celsius. You calculated the gradient. Gradient was saying that I cap plus j cap by under root 2 is my direction. So gradient is saying that you move in the direction of I cap plus j cap divided by under root 2. That means you move 1 by under root 2 in x axis and 1 by under root 2 in y axis. That means you move making an angle of 45 degree with x axis. So at what point you are reaching? Let's just say this point was A. So I am reaching at point B. What will be the coordinate of this point? What will be the coordinates of this point? Sir, I can write down the coordinates of this point. Sir, the coordinates of this particular point will be nothing but 1 plus, if I am moving for 1 unit here, that means I am moving 1 by under root 2 unit here and 1 by under root 2 unit here, because 1 cos 50, that would be 1 by under root 2 only. So I am moving 1 by under root 2 in x and 1 by under root 2 in y. So 1 plus 1 by under root 2, comma 1 plus 1 by under root 2, which is roughly around 707. So this point will become 1.707 and 1.707. So the coordinate of point B is 1.707. So what is the temperature? What is the function value? Function value is x plus y degree Celsius. So the temperature at 1.707, comma 1.707, what will be the temperature here? So that is coming out to be 3.414 degrees Celsius. So temperature here at point B, at point B, the temperature here it was 2 degrees Celsius, right? And here it has come out to be 3.4 degrees Celsius. 414 you write down, or 3.4 degrees Celsius. So this is the temperature you are getting. So how much is the change? The change in temperature is from here to here. The change in temperature is 1.4 degrees Celsius. Now this change will be the maximum change. This is what gradient will say. That means you are at 1, 1 and you are getting the temperature to be 2 degrees Celsius. Now you got a feeling that I need to get the maximum change in the temperature. So you go to gradient and you ask him, what is your direction? Gradient will say my direction is I k plus j k by under root 2. Then you go to know that if I move in the direction of I k plus j k by under root 2, then I will see the maximum change in that temperature. And you can prove it as well, that you have moved for 1 unit here, no? You have moved for 1 unit in the direction of I k plus j k by under root 2. Now I am saying you move for 1 unit from this point, you move for 1 unit in any other direction. Let's just say I am moving for 1 unit in j cap direction. Moving for 1 unit in j cap direction. So where you will reach? Where you will reach? If I move from this particular point, if I move for 1 unit in j cap direction, so at what point you will reach? How much you need to move? 1 unit. I am moving for 1 unit. I am moving for 1 unit in the j cap direction. So where you will reach? Can you let me know? Absolutely, sir. At what point you will reach? At this particular point I will reach. I am not moving in the x direction. I am only moving in the y direction for 1 unit. That means I will reach at the point 1, 2. And let's see the coordinate of this point, that is C. The coordinate of this point is C. From 1, 1 in the j cap direction, I am not moving in the direction of I cap plus j k by under root 2. What is this direction? This direction is nothing but, this particular direction is nothing but I cap plus j cap divided by under root 2. But this time I am moving in the direction of j cap. I am moving in the direction of j cap for 1 unit. I have reached to the point 1, 2. What is the temperature at 1, 2? What is the temperature? This was your point B. What is the temperature at 1, 2? 1, 2. What is the temperature? That is 3 degrees Celsius, because it is x plus y. So temperature here is nothing but 3 degrees Celsius. Is it higher than this temperature? What is the comparison between these two then? This temperature is higher, no? This temperature is higher. So no matter in whichever the direction you move, apart from I cap plus j cap divided by under root 2, let's just say someone would say that, sir, I will move in the direction of I cap. In the direction of I cap, sir, I will move for 1 unit. Let's remove this as well. So in the direction of I cap, sir, this is the direction of I cap, and I am moving for 1 unit here, sir. 1 unit I will move here. In the direction of I cap. What is this? This is the direction of I cap. So where you will reach? You will reach to the point, this was your 1, 1. So you will reach to the point 2, 1. So what is the temperature at 2, 1? Let's call this point as D. So what is the temperature at 2, 1? So that is also 3 degrees Celsius. Is it higher than 3.4 degrees Celsius? What is the temperature you are getting here? 3 degrees Celsius. So this temperature is also lower than this temperature. This temperature is also lower than this temperature. Or you move anywhere. Let's just say someone would say that, sir, I will move randomly for 1 unit here. So no matter whichever the point you will reach, I don't know which point you will reach. Okay, let's just say you moved with the angle of 60 degree. You moved with the angle of 60 degree. So what point you will reach? Let me tell you what point you will reach. This was 1, 1, no? So I am moving with the angle of 60 degree. That means in the x-axis direction, how much length I am moving? I am moving for a length of 1 unit, making an angle of 60 degree with the x-axis. So in x-axis, I will reach to the point of cos 60, that is 1 by 2. So I will reach at 1 plus 1 by 2 and 1 plus 1 by under root 2. sorry 1 plus, this is the point where I will reach. Is that understandable to you? The point will be 1.5, basic geometry it is, basic geometry, that I am moving at an angle of 60 degree. The diagram is not looking that clear here, but what they are saying that you are at 1 comma 1, you are at 1 comma 1 and you are moving at an angle of 60 degree, at an angle of 60 degree, not at an angle of 45 degree, at an angle of 60 degree. So what does that mean? You need to move for 1 unit only. Everywhere you are moving for 1 unit. Here also you move for 1 unit, here also 1 unit, 1 unit, 1 unit. So you need to move for 1 unit, making an angle of 60 degree with x-axis. That means 1 cos 60. 1 cos 60 is what? What does that mean? That means 1 cos 60. 1 cos 60 will be nothing but 1 by 2. So 1 by 2 you will move in x direction, and what is 1 sin 60? That will be under root 3 by 2. So under root 3 by 2 you will move in y direction. So at what point you will reach? Sir, from 1 comma 1 2 I will reach to the point. In x axis I moved by 1 by 2. In y axis I moved by 1 plus under root 3 by 2. You let me know the temperature. What is under root 3 by 2? That is 1.866. 1.866. So what will be the temperature? The temperature will come out to be 3.366 degrees Celsius. Is it higher? Here at this particular point, the temperature is coming out to be 3.366 degrees Celsius. Well, let's write down 3.336 only. 3.36 degrees Celsius. Is it higher than 3.4 degree? Absolutely not. 3.4 degree Celsius is still higher. This guy is still winning. This guy comes at number 2. This guy comes at number 3. But who is winning? I cap plus j cap divided by under root 2. So you are given a scalar field and you are standing at a particular point. Now you need to know that in which direction should I move such that my field will change rapidly. In which direction I should move such that my field will change the most rapidly. So you are at 1 comma 1. You calculated the gradient. Gradient would say that you move in the direction of I cap plus j cap divided by under root 2. In this direction your field will change most rapidly. So if you want to feel the highest temperature, then you move in this direction only, which is I cap plus j cap by under root 2. Is that absolutely clear or not? This is the actual meaning of gradient. How we started? Function was given. We calculated the gradient of f, which was I cap plus j cap. We saw the direction, we saw the magnitude. And what does this magnitude show? That how much temperature would change? Temperature would change by under root 2. Is that clear to you? What is the value of under root 2? Value of under root 2 is 1.4. So how much temperature is changing? The temperature at point A, here it was 2 degrees Celsius. Now here the temperature has become 3.4 degrees Celsius. Or you can say it has become under root, like temperature was 2 degrees Celsius plus under root 2. How much the temperature has become? 3.4 only, no? So this magnitude is telling how much change would be there. The change will be by under root 2. Our important thing is the direction. That I am at 1 comma 1, in which direction should I move such that I get the maximum change in the temperature. So sir, the direction would be given by the gradient. Whatever gradient is saying, you move in that particular direction, you will get the maximum change in the change in temperature. You will get the maximum change in the temperature. Is that understandable to you? So now can you understand the meaning of this particular line? The gradient tells us how rapidly a scalar field changes and in which direction at a point P. How rapidly a scalar field is changing and in which direction at a point P, where P is 1 comma 1. Is that understandable or not? A great point we have discussed. We have actually understood the actual meaning of what? Actual meaning of gradient, which 99% of aspirants do not know. They although know the meaning, but they do not have the visualization. Now you are having the visualization. That I am at 1 comma 1, I started moving in the different way. I moved in the j cap direction, I moved in the I cap direction, I moved in the direction making an angle of 60 degree. But sir, when I moved in the direction of I cap plus j cap divided by under root 2, at that direction only, sir, I got the maximum change. And everywhere I moved for the same distance. I moved 1 unit here, 1 unit here, 1 unit here, and 1 unit here. Everywhere I moved for the same distance, but sir, the maximum change I was getting, that was in the direction of I cap plus j cap divided by under root 2 only. Is that clear to you or not? Absolutely, completely clear. So this was the meaning of gradient. Understandable? Now there are some important statement about the gradient as well. This was the physical significance, but using these physical significance, we have find out two more important statement which are written in the textbook as well and could be asked in your examination as well. So this is statement 1 and this is your statement 2. Two important statements are there. Sorry, no, this is your statement 2. two important statements are there. We need to understand the meaning of these two important statements as well. Although for your examination, you might think that, sir, how they will ask question based on statement. But what they can do is that which of the following statements are true regarding the gradient. Option 1, they will frame this option. That gradient tells us how rapidly a scalar field changes and in which direction at a point P. Option 2, this statement. Which statement? This statement. Option 3, this statement. So at that time it will be helpful, no? So these statements are mentioned in the textbook, but actual meaning is not known. People just simply remember it or they don't even study it. Because in the GATE examination, sir, they cannot ask numerical problem for it, right? So they actually either they don't study it or they don't understand it. We will do both. Statement is written. Now I will understand the meaning of this particular statement. But after a break, let me take a break, drink some water, and I will come back and we will talk about the meaning of these particular statements. So statement 1, first we need to talk about a scalar field put as constant. So what it will represent? It will represent the surface, right? Let's just say my scalar field is x plus y plus z. And if I equate it to 3, what it will become? What is this? This is my scalar field. What is this? This is my scalar field. This is my scalar field, which is x plus y plus z. Now if I equate it to 3, what this will become? This will become a surface. So it is known as level surface. The name is given as level surface, constant value surface. That means on this particular surface, the value of x plus y plus z will be equal to 3 only. So 1, 1, 1 will be lying on the surface. Yes, sir. 1, 2, 0 will be lying on the surface. Yes, sir. 2, 1, 0 will be lying on the surface. Yes, sir. Minus 1, 3, 1 will be lying on the surface. Yes, sir. So on this surface, all the points whose addition is 3 will be lying. Okay, so this will become a surface. Now I need to calculate the gradient of f. If I calculate the gradient of f, then gradient of f would represent in the perpendicular direction. So if in the examination they have given you a surface and they ask you find out the surface area vector, what you will do? Surface area vector. Simply calculate the gradient. Job done. Okay, so that we will see. We will understand the meaning of this particular statement with respect to an example. The same example we are taking and we will understand it. Have some patience. Let me drink some water. You also drink some water and then I will come back. Okay. Yeah, welcome back. So we need to explain this particular statement. You can read. What you need to do is that a particular scalar field function is given. A scalar function is given. You need to equate it to a constant value. Then from there, whatever the level surface that you are getting, the surface area vector or the perpendicular vector of that level surface will be the gradient only. This is what we need to prove. As of now, you are not understanding much, but let's take the example and we will be able to understand. So I need to equate it to a constant value. So let's just say I am equating my scalar field function equals to some constant which is f equals to 2. So what I am doing? I am putting x plus y equals to 2. So is it representing a surface? Someone would say, sir, it is line only. But we are dealing in 3D coordinate system, no? If this is the function, then it is a function of x, y, z, right? So we are dealing in the 3D coordinate system. So if x plus y equals to 2, that means z can take any value from minus infinity to infinity. So what it would represent? It would represent a surface or it would represent a line. When z is 0, x plus y equals to 2. When z is 1, x plus y equals to 2. When z is 2, x plus y equals to 2. 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 So in that manner, it will be a slanted plane, right? It will be a slanted plane like this. Say yes or no. It will keep on going previously as well. So it will be a slanted plane like this. It will be a slanted plane like this. Say yes or no. Right? So it is representing a surface. Now what do I do is that I make a function phi. What I am doing? I am making a function phi. What is that? The function phi is nothing but x plus y, and I am just taking this 2 inside. So x plus y minus 2. Okay, so this is the new function phi I am making. If you calculate the gradient of this function, what you will get? Can you calculate the gradient? Yes, sir. What is the meaning of gradient? Del by del x, the full function I cap, plus del by del y, full function j cap, plus del by del z, full function k cap. Now what is the partial differentiation of x plus y minus 2 with respect to x? That will be 1 only I cap, and here you will get 1 only j cap, right? Partial differentiation of this function with respect to y. So I cap plus j cap, right? So you are getting gradient of phi as I cap plus j cap, which was the same only. If you have calculated the gradient of f or you calculate the gradient of phi, both are same only. So gradient of phi is coming out to be I cap plus j cap, or you can write down gradient of phi is magnitude is under root 2 and the direction is I cap plus j cap divided by under root 2. This is the gradient of phi you are getting at every point on the plane. Okay, it is not a function of x comma y. If it was a function of x comma y, then it would be different at other plane, but it would be different at other points. But this is the gradient you are getting on every point, for every point on the plane, for every point on the plane, for every point on the plane, on the plane. Which plane I am talking about? X plus y equals to 2. So basically you are having a plane and then you calculated a function phi which was x plus y minus 2, and you calculated the gradient. Gradient is coming out to be I cap plus j cap divided by under root 2. Now what it is representing, let's check that out. So this is the plane that we were getting, x plus y equals to 2. This equation was x plus y equals to 2, and it will be spread till infinity only. It will be spread till infinity like this. It will be spread till infinity like this, right? It will be spread backward as well. It will be spread backward as well in that manner, right? Along with that, it will be going in the negative direction as well. I am not drawing the full surface, but you would have understood how the full surface look like. Otherwise, the diagram would become messy, right? So x plus y equals to 2. Like this point will be x equals to 0, y equals to 2, x equals to 2, y equals to 0. Let's just take a simple point on this plane, which is 1, 1. What is the direction of gradient you are getting? So the direction of gradient is I cap plus j cap under root 2. Isn't it somewhat like this? Let's take another point, which is here x equals to 1, y equals to 1, and z is also equals to 1. This point will be x equals to 1, y equals to 1, and z is also equals to 1. What is the direction? I cap plus j cap under root 2. Isn't it like this only? What will be the direction here? I cap plus j cap under root 2. What will be the direction here? I cap plus j cap under root 2. What is the direction of I cap plus j cap under root 2? So isn't it the perpendicular direction to the plane? Isn't it perpendicular? So what this direction is representing? This direction is representing the direction of surface area vector. So in the examination, if they are asking find out the surface area vector for this particular surface, what you need to do? You just simply need to find out the gradient. That's it. And simply find out the direction of gradient, because direction of gradient will always be perpendicular to the surface. You can take any surface. Let's just say I am taking the surface to be z equals to 1. Z equals to 1 is a surface or not? Yes, sir. Z equals to 1 is a surface only. X, y, and z. Z will always be 1. X can take any value. X can take from minus infinity to infinity. Y can take any value. So z equals to 1 will be a surface like this. Z equals to 1 will be a surface like this. Now I already know perpendicular vector, sir. It would be plus az cap. This I already know. This will be the surface area vector. Now what do I do? Z equals to 1 is the surface I am having. I am defining a new function which is z minus 1. I am just taking 1 this side. Z minus 1. If I calculate its gradient, what will happen? Partial differentiation of z minus 1 with respect to x, I cap. Partial differentiation of z minus 1 with respect to y, j cap. Partial differentiation of z with respect to x, k cap. What is the answer you are getting? Sir, k cap only. Right? You can find out the gradient. No, the gradient is coming out to be k cap only. What does that mean? That means it is representing the direction. What is your gradient? Gradient is coming out to be k cap. And k cap is the direction of your surface area vector as well. So gradient always points towards the direction of surface area vector. So in any question, in any surface, if you are supposed to find out the direction of surface area vector, what you will do? You will calculate the gradient and find out the direction of gradient. Your job would be done. Is that understandable to you or not? And this is what has been written here. What has been written here? That f of x comma y comma z is a scalar field. Now I am equating my scalar field to a constant. Now this f of x comma y comma z equals to constant. What this is representing? This is representing as surface. This will represent as surface, or it is known as level surface. So this will represent a level surface. Now if you need to find out the surface area vector, if you need to find out the surface area vector, then what you would do? You would take help of a tool which is known as gradient. Okay, gradient of what? Look, gradient of f also you can take. But who knows the function is given in this manner? Let's just say your plane is mentioned somewhat like this, 2z minus 1. If your plane is mentioned somewhat like this, this is the equation of your plane. So what you need to do is that you make new function phi, which will be 2x plus 3y, and take this side, minus 2z plus 1. So this new function phi I will take, and I will take its gradient. What the gradient would come out to be? You can calculate the gradient. Partial differentiation of this function with respect to x will be 2i cap plus 3j cap minus 2k cap. This will be the gradient you will be getting, and this will point in the direction of surface area vector. But we will talk about the unit vector, no, because this will have some magnitude as well. So what I will do is that I will divide by its magnitude. That would be 2 square plus 3 square plus 2 square. This will be the answer. Okay, so divided by under root 17. So this will be the direction of surface area vector. Is that understandable to you? This is how I can find out the direction of surface area vector. Say yes or no. Okay. So this is what has been written here. Although they have written directly del f perpendicular equals del f will be perpendicular to f equals to c. Directly they have written, or you can think that I will take the surface. This is my surface. I will assume a function phi which is f of x comma y comma z minus c. What I will do is that I will assume a function phi which will be f of x comma y comma z minus c, and then what I will do is that I will calculate its gradient. Okay, so whatever I will calculate its gradient. So what it will have? It will have some magnitude as well, and it will have a direction as well. Both things it will have. So this direction will be same as the direction of surface area vector. Surface area vector. Or you can say it will be perpendicular to the surface. Perpendicular direction to the surface. Perpendicular direction to the surface. Is that understandable to you? And directly here we have seen that this is the slanted surface that I am getting, sir. Slanted surface I am getting. So this will be the direction of my surface area vector. Okay, I cap plus j cap under root 2. So simply, sir, any surface is given. What you need to do is that you assume a function phi and you calculate its gradient, and that will represent the direction of surface area vector, or you can say it will represent a perpendicular vector from the surface. This is the surface and it will represent the perpendicular vector. And what is the perpendicular vector? Perpendicular vector is the surface area vector only, because I told you for a particular surface what will be the direction of surface, that will be perpendicular to the surface. So perpendicular to the surface, or you call it surface area vector, or you call it direction of gradient. Both are the same thing. What I mean to say is that direction of gradient is same as direction of surface area vector. Direction of surface area vector. Surface area vector. And that is same as perpendicular direction. Perpendicular. That is same as perpendicular direction to the surface. To the surface. All three are the same thing. Is that understandable to you? Now the point is, someone would say that, sir, you have taken only one kind of vector. No, let's just say, sir, this is the surface. Let's just say this is the surface. You are saying that, sir, this is my surface area vector. Other surface area vector could also be there, which will be other one. Are you able to understand this point? If an is my surface area vector, then minus an cap will also be a surface area vector. No. If one answer is there, then other one answer will also be there. If I am saying that my perpendicular vector is I cap plus j cap divided by under root 2, is that answer correct? Yes, it is correct, but another one is also possible. No, which will be one answer is one surface area vector would be, if I talk about surface area vectors, surface area, direction of surface area vector. I am talking about the direction of surface area vector. So if I calculate the direction of surface area vector, sir, one answer came out to be I cap plus j cap divided by under root 2. But sir, another one is possible. No, minus I cap minus j cap divided by under root 2 is also possible. Because if this is one of the vector, then another vector is also there, which is this vector, which will be below the plane, right? It will be below the plane. So if this is your I cap plus j cap divided by under root 2, then the below plane would be minus I cap minus j cap divided by under root 2. Say yes or no? Right? So sir, but if you are assuming phi as x plus y minus 2, then this is the answer you are getting, I cap plus j cap divided by under root 2. So how will I get the second answer? So second answer you will get if you assume the new function. Let's just say I am assuming a function phi dash, which is this time you take x comma y, this x and y towards the other side. What I mean to say is that I am assuming a new function phi dash I am assuming. So why did I say that 2 should come here, x plus y minus 2? You can do in this manner, no, that x plus y is going this side. That means 2 minus x minus y. So phi dash is 2 minus x minus y. And if you calculate its gradient, that you can do on your own, the gradient would come out to be minus I cap minus j cap that will be the gradient, and if you talk about the magnitude, that would be under root 2, and what will be the direction? Direction would be this. Okay, so that's the scenario you are getting. So basically two kind of function we can make. Two kind of function we can make, phi and phi dash. Two kind of functions we can make. Our next statement is based on this particular function only, which is phi. That is our next statement. But as of now, what statement we have proved? That if a level surface is given, if a surface is given, I need to find out the perpendicular vector, or I need to find out the surface area vector, or I need to find out the direction of gradient. What I will do is that I will simply take the gradient, and the direction of gradient will be pointing towards the direction of surface area vector or perpendicular direction to the surface. Say yes or no. Is that understandable too? So what if this kind of question is coming, that for a sphere x square plus y square plus z square equals to 3, you need to find out the direction of surface area vector at the point 1, 1, 1. This question is coming. What I will do? Sir, surface is given, surface is given, surface is given, level surface is given. What I will do? I will assume a function phi, which will be x square plus y square plus z square minus 3. I will calculate its gradient. The partial differentiation of this function with respect to x, that will be 2x I cap, plus partial differentiation of this function with respect to y, that will be 2y j cap, plus partial differentiation of this function with respect to z, that would be 2z k cap. This is the answer you are getting. Okay, this is the whole answer, but I need to talk about the magnitude and the gradient. I need to talk about the magnitude and the direction. So if I talk about the direction of, gradient, so what will be the direction of gradient? So that would be 2x I cap plus 2i j cap plus 2z k cap divided by under root four x square plus 4y square plus 4z square. Right, now you take this 4 outside, 4 you take outside, so answer 4 if you take outside, the answer would be 2 and 2 will get cancel out. What you are getting? X I cap plus y j cap plus z k cap divided by under root x square plus y square plus z square. If I took this 4 outside, this will become 2 and 2 will get cancel out. X square plus y square plus z square. What is the value of under root x square plus y square plus z square? That is nothing but 3 only. So what is the answer you are getting? X I cap plus y j cap plus z k cap. Value of under root x square plus y square plus z square would be nothing but under root 3. So first of all, you will remember it, that for a sphere, what is the direction of gradient? For a sphere, the direction of gradient is coming out to be x I cap plus y j cap plus z k cap divided by under root 3. This is the direction that you are getting. And isn't it the direction of surface area vector only? Isn't it the direction of surface area vector? Yes sir, surely it is the direction of surface area vector as well. So for a sphere, what is the direction of surface area vector? That you will be able to remember. That will be sir x I cap plus y j cap plus z k cap divided by under root x square plus y square plus z square. What is the value of under root x square plus y square plus z square? That would be equal to the radius. So direction of surface area vector for a sphere will be x I cap plus y j cap plus z k cap divided by the radius r. That's it. Okay, so this should be remembered. But is that the only answer? Direction could be two, no? Two directions are possible. One is outward, other one could be inward as well. Right? The other direction could be inward as well. So that direction is also possible. What does that mean? That means minus x I cap minus y j cap minus z k cap divided by under root 3. That is also possible. Understandable? Now at the point 1, 1 we need to find. Okay, direction of surface area vector. Direction of surface area vector at 1, 1, 1 we need to find. So what that would be? That would be nothing but you need to put 1, 1, 1 here. What is the answer you will be getting? I cap plus j cap plus k cap divided by under root 3. That's it. So let's just say this will be my 1, 1, 1, no? 1, 1, 1. So this is your surface. Let's just say this point is 1, 1, 1. So what will be the direction? This will be the direction. This will be the perpendicular direction, which is I cap plus j cap plus k cap divided by under root 3. So if you see this direction, isn't the direction looking somewhat like this? Isn't it the direction? This direction is nothing but, although you are taking the direction from this point, right? You are not taking the direction from the origin, but I'm just telling that this is how it would look like. No, you are not taking it from the origin. You need to take the direction at this point. Now, if you need to define this vector, how you can define this vector? If you need to define this vector, and if you take this vector back, let's just say at this point, this is my direction of surface area vector. If I take this vector backward, then what will happen is that it will end up at the origin only. Why I am sure that it will end up at the origin? Because sir, this particular thing is nothing but a vector r. This is the position vector. No, if you look at it carefully, it is the position vector. So if there is any point 1, 1, 1, then what is the position vector of 1, 1, 1? So that would be nothing but I cap plus j cap plus k cap. Position vector of 1, 1, 1 will be I cap plus j cap plus k cap only. So this particular direction is in the direction of position vector only. So this is actually position vector divided by under root 3. Position vector divided by under root 3. Or I should say position vector divided by under root 3. Position vector divided by under root 3. Right? So this is your perpendicular direction, or you can say at this particular point, this is representing the surface area vector direction of surface area vector. That is coming out to be I cap plus j cap plus k cap divided by under root 3. So similarly, in any other direction also you can take. Similarly, at any other point you can take. Let's just say this point is x equals to minus 2, z equals to 1 would be there, and let's just say this is your z, this is your x, and this is your y. Y is 1. Minus 2 is not even possible. No, 1, 1. Minus 1. Minus 1, 1, this is minus 1, 1, 1. This is the point. So what will be the direction? Sir, the direction would look somewhat like this. This is how the direction would look like. What will be the value? The value will be minus I cap plus j cap plus k cap divided by under root 3. Right? Any other point you can take. Some point downward you can take. Some point downward you can take. Some point downward you can take. What is the direction here? Some other point you can take. Some other point you can take. At this particular point, direction will be radially outward. So basically, this is how the direction would look like. I hope you are able to imagine. From the origin, all the perpendicular vectors are going out. So this is a special case of sphere actually. That's why I took this example. More examples we will take, but for the sphere, especially you need to remember the answer. What you will remember? That sir, for a sphere, the direction of surface area vector is x I cap plus y j cap plus z k cap divided by under root x square plus y square plus z square. That would be equal to the radius. So directly you should be able to write down, because it will come again and again. Okay, when we study about integral calculus, no, so it will be used again and again. So you need to remember. How did we derive it? Simply take the gradient, nothing else. Assume a function phi, which is x square plus y square plus z square minus 3. Take the gradient, you are getting your answer. Again and again, I am not going to show the gradient. Directly I will write down the direction. Understandable? So any function, if they give, you will be able to write down the direction. So is this statement clear to you or not? Statement 1, is this clear or not? Absolutely, sir. Completely clear. That if there is a function given, I equate it to a constant value, it will become a surface. Then I assume a function phi, which is f minus c. If I calculate its gradient, it is pointing towards the direction of surface area vector. That's it. Which will be perpendicular to the surface. Because direction of surface area vector is perpendicular to the surface. Well and good. Absolutely clear. Completely clear. Let's see the next statement. This is also related with phi only. That you make phi, which is x, y, z minus c, you calculate its gradient, then where the phi will be pointing, this is what they are asking. So let's ignore these lines first. Let's understand the statement, and then we will come back to this particular statement and we will read it. Okay. So let's understand the statement first. So what it is saying? Your function is x plus y. Now what I am doing is that I am equating it to a constant value, and from there I am making a function phi, which is x plus y minus 2. Let's just say it is representing the temperature only. Okay. So what did I do? I marked out all those points where temperature is 2 degrees Celsius. What I am doing is that I am making this plane. On this plane, at every point temperature is 2 degrees Celsius. Do you agree to this point or not? This is the plane of, on this plane, what is the value? On this plane, the value of x plus y is 2 degrees Celsius. That means on this plane, with z going from minus infinity to infinity, with z going from minus infinity to infinity, on this particular plane, the value of temperature is minus 2 degrees Celsius. Say yes or no. Right? So I have made this plane. On this particular plane, the value of temperature is 2 degrees Celsius. This is what I have done. Now I have made a new function phi. I have made a new function phi, which is x plus y minus 2. Now on this plane, what is the value of phi? On the plane, I am asking about the value of phi, not the value of temperature. On this plane, the temperature is 2 degrees Celsius. I am asking on the plane, what is the value of phi? Sir, on the plane, value of x plus y is 2 degrees Celsius. On the plane, sir, on the plane, what will be the value of phi? Sir, value of x plus y is 2. On the plane, value of x plus y is 2. So 2 minus 2, value is 0. So on the plane, on this plane, the value of phi is 0. On the plane, the value of phi is 0. Say yes or no. Absolutely clear, sir. Now if I calculate the gradient, what we are getting? If I calculate the gradient, what I am getting? If I calculate del phi, I am getting I cap plus j cap divided by, this is the gradient I am getting, or I can write down, because I am interested more in the direction. Magnitude is under root 2 I cap plus j cap divided by under root 2. So what is the direction? Direction is I cap plus j cap divided by under root 2. This is the direction. Can you show on this plane? Yes, sir. I cap plus j cap divided by under root 2 would be looking somewhat like this. At every point, it would be looking somewhat like this. So let's just say this is the plane. So I cap plus j cap by under root 2 is pointing here, right? I cap plus j cap by under root 2 is pointing here. Now on the surface, the value of phi is 0. Let's take some point above the plane. That means let's take some point here. Let's just say I am taking this point which is above the plane. I am taking a point which is above the plane. So what is this point? Sir, this point is 1, 1. So let's take some point which is 2, 2, 3. Right? 2, 2, 3. Is it above the plane? Is this point above the plane? This is the plane. Here below the plane, what is the point? This point. 0, 0 is below the point, below the plane. 0, 0, 0. Is it below the plane? Yes, sir. 0, 0 is below the plane. I am taking a point above the plane which is 2, 2, 3. Is it above the plane? Absolutely, sir. So at this particular point, what is the value of phi? I am asking what is the value of phi at this point? What is the value of phi at 2, 2, 3? So that would be x is 2, y is 2, minus 2. The value of phi is 2 only. At 2, 2, 3, the value of phi is 2. Here, what is the value of phi? That is 2. Let's take some other point. What is this point? This point is 2, 0. Right? Because this equation is x plus y equals to 2 and this point is 0, 2. Let's take some point above the plane. I need to take some point which is above the plane. So let's take this point where x is 3, y is 2, y is 1 and z is 0. Is it above the plane? Yes, sir. What is the value of phi here? What is the value of phi at 3, 1, 0? So that would be 3 plus 1 minus 2. So that is also coming out to be 2 only. So here also, sir, phi is coming out to be 2. Is it greater than 0? Is it greater than 0? Yes. Is it greater than 0? Yes. Let's calculate the value of phi below the plane. Over the plane, value of phi is 0. Above the plane, value of phi is greater than 0. Below the plane, what is the value of phi? Below the plane, what is the value of phi? The value of phi below the plane is 0, 0 below the plane. 0, 0, 0. Is it below the plane? Absolutely, sir. What is the value of phi? Put 0, 0, 0 plus 0 minus 2. What is the value of phi you are getting? So the value of phi I am getting is minus 2. So below the plane, the value of phi I am getting is here. The value of phi that I have got is phi is coming out to be minus 2. Let's take some other point. Any point you can take below the plane. This point will be below the plane only, no? What is this point? So this point is x equals to 1, y equals to 0. Below the plane only, and z is also equals to 0. Here also I should have shown 0 only. Because z point also you need to show, no? You are dealing in 3D. So let's calculate the value at 1, 0, 0. What that would be? 1 plus 0 minus 2. What is the value? Minus 1. So here, what is the value of phi you are getting? Here the value of phi is coming out to be minus 1, minus 2. So what did you notice? That, sir, above the plane, value of phi is greater than 0. Above the plane, on plane, first of all, you let me know on the plane, what is the value of phi? Sir, on the plane, value of phi is 0. Above plane, what is the value of phi? that is phi greater than 0. And below plane, what is the value of phi? Phi is less than 0. Now, what is the direction of gradient? This was my plane. Here phi is greater than 0. Here phi is less than 0. Here phi is equals to 0. Again, this is my plane. Phi greater than 0. Phi equals to 0. Phi less than 0. What is the direction of gradient? This is the direction of gradient. So, what is the direction of gradient? Where gradient is aiming? The gradient is aiming from phi less than 0 to phi greater than 0. So, gradient is pointing towards phi greater than 0. Do you agree to this point or not? At phi equals to 0, here I find out the direction of gradient that came out to be this. So, gradient is always pointing towards phi greater than 0. Do you understand this point or not? Sir, I assumed a function phi which was x plus y minus 2. Okay, sir, very good. Now, if I calculate the gradient, that is coming out to be, sir, under root 2 into I cap plus j cap by under root 2. So, the direction of gradient is I cap plus j cap divided by under root 2. What do you want to prove from it? I want to prove a point that, sir, on the plane, the value of phi is 0. Here, the value of phi is greater than 0. Here, the value of phi is greater than 0. Here, the value of phi is less than 0. If I see the direction of gradient, the direction of gradient is always towards from phi less than 0 to phi greater than 0. There you go. This statement has been written here. On a surface, phi equals to 0. On one side of surface, phi greater than 0. On other side of surface, phi less than 0. Hence, the gradient always points from the region where phi is less than 0 towards the region where phi is greater than 0. Equivalently, gradient of f would be equals to gradient of phi, which will be pointing towards the region phi greater than 0. Is that understandable to you or not? Every statement of these are written in the textbook, but no one actually understands it. Okay, and people usually ignore it. I'm telling you, in the examination, if they want to frame a good question, this is how the question would be framed. Which of the following statement regarding the gradient is true? MSQ question. Question number 1, option number 1 will be this. The gradient tells how rapidly a scalar field changes and in which direction at the point P. Statement number 2, level surface, it will represent the perpendicular vector. Statement number 3, it will point towards phi greater than 0. Statement number 4, it will point towards phi less than 0. Which of the following statements are true? This kind of question would be framed. And if you have studied gradient only by the formula, then you will not be able to solve. Because these are very, very important statements which are written in the textbook. Say yes or no. Are you able to understand the meaning of all these statements? If I would have gone mathematical, then everything will be messed up. So without going mathematical, I took some example and this is how I am explaining the actual meaning of gradient. Is that understandable or not? I hope the actual meaning of gradient is being understandable to you. It is being clear to you. But now here as well, there would be one more doubt that, sir, what about phi dash? What about phi dash, sir? One function you took here, no? Phi dash. Where is that phi dash? Yeah, this phi dash you took, which is 2 minus x minus y. So, sir, what about phi dash? Where phi dash is representing? So let's talk about phi dash now. What I am doing, I am assuming another function which is phi dash. So different guy can think in different manner, no? What if someone would have made the function as 2 minus x minus y? Right? So first of all, you need to draw the equation of this plane. I have drawn the equation of this plane again. On this plane, what is the value of x plus y? Sir, value of x plus y is 2 degrees Celsius. But what is the value of phi dash here? Sir, value of phi dash at on this plane, value of phi dash on this plane, value of phi dash on the plane is nothing but 0. Value of phi dash on the plane is nothing but 0. Say yes or no. Now can you calculate del phi dash? Yes sir, it will come out to be minus I cap minus j cap divided by under root 2. That means on the plane where it will point minus I cap minus j cap divided by under root 2. That means it is pointing downward. It is pointing downward. Now my question is the gradient pointing towards phi dash greater than 0? Look, here what is the statement written? The gradient will always points from phi less than 0 to phi greater than 0, no matter how you define your phi. If I define my phi in this manner as well, no? C minus f x comma y comma z. This is how I have defined it, no? This time I have defined my phi in this manner, which is c minus x minus y. So what is the direction of gradient I am getting? The direction of gradient I am getting is minus I cap minus j cap divided by under root 2. So direction of gradient I am getting is minus I cap minus j cap divided by under root 2. Is it pointing towards phi greater than 0? Absolutely. Why is that so? Because below the plane, what are the points? Below the plane, what are the points? Sir, below the plane, there is a point which is 0, 0, 0. This point is below the plane, right? This point is below the plane. Now calculate the value of phi dash at 0, 0, 0. What is the value you are getting? Sir, 2 minus 0, 0, 0, that is 2, which is greater than 0. And calculate the value of phi dash at some point which is above the plane. Let's just say I calculate the value of phi dash at 2, 2, 3. Is it above the plane? Absolutely, sir. So I calculate the value of phi dash at 2, 3. What is the value I am getting? Sir, 2 minus 2 minus 2, which will be minus 2, which is less than 0. So above the plane, the value is phi dash less than 0. And here what is the value? Phi dash greater than 0. And here what is the value? Phi dash equals to 0. What is the direction of gradient? Direction of gradient is downward. This was my surface. The direction of gradient is coming out to be downward. Direction of gradient is coming out to be downward. Direction of gradient is coming out to be downward. Is it representing? Is it pointing towards phi dash greater than 0? Absolutely. It is pointing towards phi dash greater than 0. So always it will point from phi dash less than 0 to phi dash greater than 0, no matter how you are defining your function phi. Someone would define the function in this manner, f of x comma y comma z minus c, and someone would define c minus f of x comma y comma z. Is that understandable to you or not? All three statements absolutely clear or not? Very, very hopeful I am that this kind of statement is soon coming in your examination hall, because till this point it has not come, and surely they are going to frame some question out of it. That scalar field function is given, I equate it to a constant value which will become a level surface. Now I define a function phi which is f of x comma y comma z minus c. Now if I calculate the gradient of phi, the direction of gradient of phi will point towards what? It will point from phi less than 0 to phi greater than 0. That means it will be always pointing towards phi greater than 0. The next statement would be that if I define my function phi in the manner that phi equals to c minus f of x comma y comma z, then what will happen? Where the gradient of phi would point? Again it will point towards phi greater than 0 only. Here as well it is pointing towards phi greater than 0 only. I have taken the phi dash this time, which is a different function. Is that clear to you or not? And how does it point? It points perpendicularly, perpendicular to the surface, which is f of x comma y comma z equals to c. Every single point regarding the gradient to the point, everything is crystal clear. They cannot trouble you in gradient at all. Say yes or no. I hope you are enjoying the lecture series. Okay, revise it once again. I know it is not very straightforward. I could have ignored it. I could have simply started with the question, but this is something that I did not want to do. I want to give you the concept of gradient as well. I want to give you the actual meaning of gradient as well. I could have stopped here only that this is what they would represent and let's get started with the question. But wouldn't make any sense. You are an engineer. I am not teaching some JEE aspirants here. You are a GATE aspirant. You are going to do the work of engineering. That's why these points are necessary as well. I cannot avoid it. If you are someone who wants to study the crash courses in 50-60 hours, then this channel is not for you. Okay, here we study the things comprehensively and this is how we study the things. Is that understandable to you? I hope every single thing regarding gradient, magnitude, direction, everything is crystal clear. That what it represents, what is the meaning of every single statement. So first of all, it will let you know that in which direction you should move such that you get the most rapid change. First statement was that at a particular point, if you have calculated a gradient, so from this particular point, in this particular direction you need to move so that you will get the maximum change. First statement. Second was that if you are given a surface, then if you calculate the gradient, it will always point towards the normal to the surface, or you can call it is the direction of surface area vector, because normal to the surface and direction of surface area vector both are the same thing. So if you need to find out the direction of surface area vector, then what you need to do is that you need to take help of the gradient. You calculate the gradient and you will get the direction of surface area vector. We solved one example. That example is saying, we solved one example as well, and from that example we need to remember one thing, that for a sphere the direction of surface area vector would be x I cap plus y j cap plus z k cap divided by under root x square plus y square plus z square. So we will be remembering it because it will be used again and again when we study about vector integral calculus. There it will be used again and again. Secondly, if I assume a function phi which is f of x comma y comma z minus c, or if I assume a function phi which is c minus f of x comma y comma z, then if I calculate the gradient of phi, it will always points from phi less than 0 to phi greater than 0. Understandable? Job done? Absolutely. Okay, and after that we simply need to solve the questions now. Questions on gradient: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 question we need to solve, and everything will be crystal clear. Is that clear to you? So let's get started with the first question. Sir, you did not tell the meaning of directional derivative. So I will tell the meaning of directional derivative now. So first of all, what is given? You are given a scalar field. You are given a scalar field which is x square plus y square. You need to find out that directional derivative of f of x comma y at point 1 comma 2. I don't know what is the meaning of directional derivative. Let's find out the gradient first. Okay, gradient first. I am finding out the gradient. Sir, why you are finding out the gradient? You will understand. So if the question is based on directional derivative, no, that means you need to find out the gradient for sure. So let's find out the gradient. Sir, partial differentiation of this function with respect to x. Answer will be 2x I cap plus partial differentiation of this function with respect to y, 2i j cap plus partial differentiation of this function with respect to z, 0 k cap. What answer you are getting? So 2x I cap plus y j cap. This is the gradient of f you are getting. Now let's find out the gradient of f at 1 comma 2. 1 comma 2. That would come out to be I cap plus 2 j cap. Right? This is what you are getting. At 1 comma 2, it is coming out to 2 into I cap plus 2 j cap. That means if you are at 1 comma 2, if you are at 1 comma 2, if you are at 1 comma 2, then if you move in the direction of 2 into I cap plus 2 j cap, if you move in this direction 2 into I cap plus 2 j cap, then you would get the maximum change. How much change you will get, that also I can find out. If you are at 1 comma 2 and if you move in the direction of, although there is some magnitude, but the direction would be I cap plus 2 j cap. In this direction if you move, then you will get the maximum change. But the user is asking, what if I move in the direction of 4 I cap plus 3 j cap? Let's just say 4 I cap plus 3 j cap is here. This is my 4 I cap plus 3 j cap. So if I move in this direction, if I move in the direction of, first of all they are asking in the direction of vector. In the direction of vector, direction of vector, direction of vector 4 I cap plus 3 j cap. So what will be the direction of vector? Direction, if they talk about direction, what does that mean? That means you need to calculate the unit vector. So that would be 4 I cap plus 3 j cap divided by under root 4 square plus 3 square. That would be this, right? So what is the answer you are getting? The answer that I am getting is 4 I cap plus 3 j cap divided by under root 4 square plus 3 square, which will be 5. So what they are saying? First of all, you understand the meaning of this statement. Direction of the vector 4 I cap plus 3 j cap. That means you need to move in the direction of 4 I cap plus 3 j cap divided by 5. So they are saying that I know that if I move in the direction of 2 I cap plus 2 j cap, then I would get the maximum change. But how much change will I get if I move in this direction? And that is known as directional derivative. Is that understandable to you or not? So let's write down that directional derivative. What is the meaning of a directional derivative of f at x naught comma y naught comma z naught in the direction of a vector will be what? Now I know that if I move in this direction, then I will get the maximum change. I need to find out the change that I will get if I move in the direction of 4 I cap plus 3 j cap plus 5. What do you think what I should do? If I move for 1 unit here, let's just say this angle is 45 degree. Okay. If I move for 1 unit making an angle of 45 degrees, then which point I will reach? Where I will reach? I will reach at 1 by under 2, 1 by under 2. Right? Now, if I want to know that where I will reach in the direction of I cap, how much will I reach? Then what I need to do? I need to take the component of this one in the direction of I cap. No? If I am moving in the direction of vector A, this is how I will move. So if you are moving in the direction of A, then this much you have moved. How much you would have moved if you walk in the direction of B cap? What you will do? You will calculate the projection of A. You will calculate the projection of A on B. What will be the projection of A on B? That would be A vector dot B cap. So similarly, I know that when I move in this direction, then this is the maximum. If I move in the direction of 2 into I cap plus 2j cap, then I would get the maximum change. But they are asking, what if you move in the direction of 4 I cap plus 3j cap divided by 5? Then how much change you will get? That means I need to calculate the component of 2 I cap plus 2j cap in the direction of 4 I cap plus 3j cap divided by 5. Slowly you will understand. We will solve a lot of questions. Have some patience. So directional derivative of f, that means what you will do? Gradient of f at x naught comma y naught comma z naught. If they are asking directional derivative of f, that will be replaced with the gradient of f. Gradient of f at x naught comma y naught comma z naught in the direction of vector A. Or you can write down component of, or you can write down component of gradient of f, component of gradient of f at x naught comma y naught comma z naught in the direction of A vector. Right? What does that mean? Component of gradient of, first of all, why it is vector? It is not vector. Component of gradient of f. Let's just say gradient of f is nothing but A vector. Sorry, gradient of f is nothing but a B vector, or let's call it a C vector. So component of vector C, what I am saying is that gradient of f is nothing but a vector C. It will be a vector quantity, right? Gradient of f is vector quantity. So component of C vector in the direction of A vector, what that would be? So that would be nothing but C cos theta. That would be nothing but C cos theta. And C cos theta would be written as C vector dot A cap. Right? So what is the answer you are getting? C vector is nothing but delta f only. Right? Dot A cap. So this is known as directional derivative. So this is shown as directional derivative of f at point x naught comma y naught comma z naught in the direction of A. So directional derivative of f, that means you need to calculate the gradient. So gradient of f at x naught comma y naught comma z naught in the direction of A. In the direction of A, that means direction of A means you need to take A cap. So you need to find out the component of your gradient in the direction of A. This is the meaning of directional derivative. We will solve a lot of numerical. It will be absolutely fit in your mind. So did you understand the meaning of directional derivative? First, my target was to let you understand the meaning of directional derivative. Everyone would remember what is the way of solving the problem. But did you understand the meaning of directional derivative? The meaning of directional derivative is that, sir, if I move in the direction of 2 into I cap plus 2j cap, then I will get the maximum change. But I want to know that what will be the change if I move in the direction of 4 I cap plus 3j cap divided by 5. So let's find out that change. What is your gradient of f? So gradient of f is coming out to be 2 I cap plus 2j cap. Right? 2 I cap plus 2j cap. Dot product with 4 I cap plus 3j cap divided by 5. 4 I cap plus 3j cap divided by 5. So what is the answer you are getting? 2 into 4 plus 6. 2 into 4 plus 6 divided by 5. So answer we are getting is 4. What is the answer? This is the answer that we are getting, that is 4. Right. Now let's do one thing. Let me know the magnitude of gradient of f at this point 1 comma 2. What is the magnitude? So the magnitude is under root 2 will be outside, under root 1 square plus 2 square. So sir, magnitude is 2 into under root 5. What is the value of 2 into under root 5? Let's calculate the value. 2 into under root 5. What that would be? Just to take the calculator, and 2 into under root 5. So that is 4.47. What does that mean? That means if you move in this direction for 1 unit, if you move in this direction for 1 unit, then your change would be 4.47, right? But if you move in this direction for 1 unit, then what will be your change? That will be 4. This is what it is saying. I hope, areva, answer is coming out to be 2. Wait a second, क्या कर पड़ो गई? 2x I cap 1,2 पे 1,2 हो गया. 2 into I cap root 2 j cap in the direction 4 I cap plus 3 j cap divided by under root 4 square plus 3 square 9, 16 plus 9 5, then 2 into 4 plus 6 10 20 divided by 5. Nothing wrong here yaar. Answer is 4 only, no? Answer is 4 only, that is wrong. Answer will be 4 only. Nothing wrong here. Say yes or no. At 1 comma 2 I cap. The answer will be 4 only. Okay. In the direction of 4 I cap plus 3 j cap. This was 2 I cap plus 2 j cap, and unit vector I need to find out in the direction of the vector 4 I cap plus 3 j cap. So 4 I cap plus 3 j cap divided by 5. So absolutely the same answer we are getting. Yeah, 4 answer is the correct. So what is your directional derivative representing? It is saying that your function is, your scalar field function is x square plus y square. Sir, if you are at 1 comma 2, you are at 1 comma 2, at 1 comma 2, sir, the value is 5. The value of this, let's say it is degree Celsius only. So here the temperature is 5 degrees Celsius. Now sir, if you move in the direction of 2 into I cap plus 2 j cap, then you will get the, sir, maximum change in the temperature. Okay, and that change would be, sir, for per unit, that change would be 4.47 degrees Celsius. This is what you can say. Then someone came and asked you, what if I move in the direction of 4 I cap plus 3 j cap? So what is the meaning of direction? So that meaning of direction is a cap. That means what if I move in the direction of 4 I cap plus 3 j cap divided by 5? So if I move in this direction, then let me know what will be the change. I know that if I move in this direction, then change is 4.47 degrees Celsius. But what if I move in the direction of 4 I cap plus 3 j cap divided by 5? So what will be the change? Then what you did was, you took the component of this vector on this particular vector. You took the component of this vector on this particular vector, and that came out to be, this was your c vector. So this component came out to be c cos theta. C cos theta. So you just find out the component as c cos theta could be written as vector c dot a cap. And this vector was a vector only. Or you can call it a cap only, because this is a cap. So c vector dot a cap was your answer. There you go. Is that understandable to you? I hope it is completely understandable. These kind of questions are very, 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 very famous in the examination hall. Simply take the gradient and take the component of gradient in the direction of vector A. That's it. This is what you need to do. Even if you don't know the physical meaning, then also it is fine. I hope you know what you need to do in the examination hall. Directional derivative, if they are asking, that means you calculate the gradient and now take the component of gradient in the direction 4 I cap plus 3 j cap. Next question, think about it and let me know the answer. No, first this question we need to solve. Scalar field function is given. You need to find out the maximum value of directional derivative at this point. Maximum value of directional derivative. What do you think? What it will represent? Maximum value of directional derivative. Think about it. What will represent the maximum value of directional derivative? Maximum value of a directional derivative. Sir, that will be simply equals to the magnitude of gradient. Say yes or no. Because directional derivative here, what directional derivative was representing? Directional derivative was representing, what is the answer you got? 4. So directional derivative was saying that if you move in the direction of 4 I cap plus 3 j cap, no, then your change will be 4. Now what they are asking, that with the help of directional derivative, you let me know what will be my maximum change. So sir, maximum change you will get in the direction of gradient only. And how much change you will get? So that will be equals to the magnitude of the gradient. So if they are asking the maximum value of directional derivative, that means they are asking nothing but the magnitude of gradient only. Because if you move in the direction of gradient, then we get the maximum change. What they are saying, maximum change, maximum value of directional derivative means the maximum change you get, maximum change you get in the direction of gradient only. Just calculate the direction of gradient and you will get the maximum change. So what I need to do is that I need to calculate the gradient of phi. What is the gradient of phi? Partial differentiation of this function with respect to x, that will be 4x I cap, plus partial differentiation of this function with respect to y, 6y j cap plus 10z k cap. Gradient of phi at the point 1 comma 1 comma minus 1, that will come out to be 4 I cap plus 6 j cap minus 10 k cap. What will be the magnitude? So magnitude would be 4 square plus 6 square plus 10 square. So 100 plus 36 plus 16. 12.32. 12.32 is the answer that you are getting. Under root 152, yeah, 12.32 is the answer that we are getting. That means if you move in the direction of 4 I cap plus 6 j cap minus 10 k cap, then you will get the maximum change, and that change would be 12.32 only. Understandable? Is that clear to you? Okay. Next question. Scalar field function is given. Find the magnitude of directional derivative at the point 1 comma 1. Till this point, what you understand? You need to find out the directional derivative of f at 1 comma 1. What does that mean? I need to calculate its gradient. What is the gradient you are getting? So partial differentiation of with respect to x and then partial differentiation with respect to y. This is the gradient I am getting. Gradient at what point? At 1 comma 1. 2 I cap plus 6 j cap. First this job is done. Now what you need to do? In the direction normal to the circle, x square plus y square equals to 2. What is the direction normal to the circle? Normal to the circle. Direction normal to the surface. Direction normal to the circle. Direction normal to the circle, which is x square plus y square equals to 2. If you need to find out this particular thing, direction normal, what you can do? You can make a function phi, which is x square plus y square minus 2, and you can simply calculate its gradient. That will come out to be 2x I cap plus 2i j cap. And if you need its direction, because you need the direction means unit vector. If you need the unit vector, what you need to do? 2x I cap plus 2i j cap divided by under root 2x square plus 2i square. So what you are getting? 2 you take outside, I cap plus j cap, x I cap plus y j cap under root x square plus y square. What is under root x square plus y square? Value of under root x square plus y square is given as under root 2. So you are getting x I cap plus y j cap divided by under root 2. So what you understood here? Direction normal to the circle, direction normal to the circle, direction normal to the circle is nothing but x I cap plus y j cap divided by under root 2. And if they are asking at some point, at point 1 comma 1, then simply put 1 comma 1 here. That would be I cap plus j cap divided by under root 2. So what you need to do? You need to find out that directional derivative of f in the direction of I cap plus j cap divided by under root 2. You need to find out the directional derivative in the direction of I cap plus j cap divided by under root 2. First of all, you understood the meaning of this statement. That means I need to calculate the gradient. In which direction? In the direction of I cap plus j cap divided by under root 2. What was given? In the direction of normal to the circle, normal to the circle. What is the direction which is normal to the circle? So normal to the circle direction will be x I cap plus y j cap divided by under root 2 only. At 1 comma 1, the direction would become I cap plus j cap divided by under root 2. Right? Okay. So now I have found out the perpendicular direction. Understandable? So what is my question now? You need to find out magnitude of directional derivative of f in the direction normal to the circle x square plus y square equals to 2. That means you need to find out the component of this vector. Let's just call it c vector, and let's just call it a cap. Component of c vector in the direction of a. In the direction of a, what that would be? C vector dot a cap. What is your c vector? So that would be 2 I cap plus 6 j cap dot I cap plus j cap divided by under root 2. So 8 by under root 2, answer is 4 under root 2. That's the answer that we are getting. That's it. Okay. So how to solve these kind of problems? I hope it is clear to you. 4 under root 2 is the answer. So first of all, you see directional derivative of this point at the particular point. So you find out the directional derivative first. Job done, sir. We have find out the directional derivative. Now, sir, since we have find out the directional derivative now I need to find out in which direction I need to find out the directional derivative. So then I need to find out the direction. This is the direction. This is the direction. So first you take the gradient, then you find out the direction. Then what you need to do is that gradient in this direction, component of gradient in this direction. That means c vector dot a cap. Job done, answer done. Next question, again the same kind of question. Scalar field is given, directional derivative of x of f at this point. Directional derivative of f at point A. So what you need to do? Sir, I need to calculate the gradient of f. What will be gradient of f? Sir, partial differentiation of this function with respect to x. Partial differentiation of this function with respect to x, which is xy plus yz plus zx. So what will be the partial differentiation of this function with respect to x? So that would be nothing but with respect to x. So y will be taken as common, partial differentiation of x will be 1. Yz, that will be 0. Then x will be taken as common, y plus z I cap. Plus partial differentiation of y with respect, partial differentiation of this function with respect to y. Partial differentiation of this function with respect to y. So what that would be? With respect to y you need to differentiate. So x will be common. Then z will be common. So x plus z j cap plus partial differentiation of the function with respect to z. So xy plus yz plus zx. So 0. Here what you need to do? Y common plus x k cap. This is your gradient of f. Okay. At what point? 1, 2, 3. Gradient of f at what point? 1, 2, 3. 5 I cap plus 4 j cap plus 3 k cap. This is the gradient that you have got. Now you need to calculate the gradient in the direction of vector AB. In the direction of vector AB. In the direction of vector AB. What will be the direction of vector AB? I hope you know that vector AB could be written as vector B minus vector A. Right? Position vector of B minus position vector of A. What is position vector of B? That will be 3 I cap plus 3. Basically, you will make the line AB. No. AB vector I am supposed to find out. So can I make the line AB? Can I make the line AB? This will be point A. This will be point B. I need to find out AB vector. What is your coordinate of A? 1, 2, 3. What is the coordinate of B? That is 3, 3, 1. Right? So what will be your AB vector? Sir, AB vector would be 3 minus 1, 2 I cap plus j cap minus 2 k cap. 3 minus 1, 2 I cap, 3 minus 2 j cap, 1 minus 3 minus 2 k cap. This is your AB vector. Right? So you need to find out that directional derivative in the direction of this. In the direction of this, that means you need to find out AB cap. So since I have find out the gradient, what it is? It is C vector. Right? Now what I need to find out? AB cap. What is my AB cap? So that would be 2 I cap plus j cap minus 2 k cap divided by under root 2 square plus 1 square minus 2 square. So what is the answer? 3. So 2 I cap plus j cap minus 2 k cap divided by 3. So what we can call it? Previously what we used to call it? We used to call it a cap. So here let's call it p cap. P cap. So vector c in the direction of p cap. What will be your final answer? Vector c in the direction of p cap. So what is my vector c? Which is 5 I cap plus 4 j cap plus 3 k cap. So simply the task is that first you need to find out the gradient. First you get the gradient at a particular point. Then you look for the direction. In which direction I need to find? So sir, I need to find out that in the direction of AB. So in the direction of AB you need to find out. So find out the direction of AB. What is the direction of AB? So that is coming out to be 2I cap plus j cap minus 2k cap divided by 3. So what does that mean? I need to take the component of C vector in the direction of P vector. So this is the answer that we will be getting, and let's see the answer now. So this AB vector separately we have calculated that we can keep in some box, separate box. So 5 into 2, 10 plus 4 minus 6 divided by 3. So answer is 8 by 3. Is that correct? 8 by 3 is correct. Okay. So answer is coming out to be 8 by 3. That's the answer that we are getting. Okay. So 8 by 3 is the answer. So simple process is there. Directional derivative at a point. That means gradient at a point. In which direction? Calculate the direction, do the dot product. That's it. Okay. Simple process is there, and very important, I would say very important. A lot of questions have been asked from this particular topic in the examination. I don't know why. Second question, scalar field is given, find the directional derivative. First of all, directional derivative of phi at a particular point. What does that mean? First of all, sir, I am supposed to calculate the gradient. Partial differential of this function with respect to x, 4x I cap. Partial differential of this function with respect to y, 6y j cap. Partial differential of this function with respect to z, 10z k cap. Add point 1, 1, minus 1. That would be 4 I cap plus 6 j cap minus 10 k cap. In the direction normal to the surface. In the direction normal to the surface at a point 1, 1, 1. So you are supposed to find out the directional derivative here. Okay. You are supposed to find out the directional derivative at this point. But normal you need to take at this particular point. Are you able to understand this point? You need to take the normal at this particular point, which is 1, 1, 1. Basically, there is a sphere. On this sphere, there is a point 1, 1. There is a point on this sphere. There is a point which is 1, 1. You need to find out the normal vector here. Okay, you need to find out the normal at this particular point. Whatever the normal that you get, that will become your A vector. Okay, so you need to find out the normal at this particular point, which is 1, 1. So for a sphere, what is the normal? For a sphere, what is normal vector? What is your normal vector? So sir, for a sphere, the normal vector is nothing but, I know already, xi cap plus yj cap plus zk cap divided by the radius. What is the radius? The radius is under root 3. This will be the normal vector. And I need to find it out at 1, 1. So I will put the value 1, 1. I will put the value 1, 1. So the question was that you need to find out that directional derivative of phi. You need to find out the directional derivative of phi at point 1, 1, minus 1 in the direction of I cap plus j cap divided by under root 3. So what you need to find out? You need to find out the directional. You need to find out the component of C in the direction of A cap. So you need to find out 4I cap plus 6j cap minus 10k cap in the direction of I cap plus j cap plus k cap divided by under root 3. So answer will come out to be 0 only. Okay, you can simply see 4 plus 6, 10, answer is 0. It is a GATE PYQ only actually. So what is the answer? It is 0 only. Okay, answer is 0. Let's move to another question. Let's see this question. Let the scalar field is given. Particle move along the curve. Directional derivative at point. What I will see? Directional derivative at point 1, 1. So first of all, there you go. So partial differentiation of this function with respect to x. So first I will do the partial differentiation of x square y. That will become 2xy plus partial differentiation of 2yz, that would be 0. Partial differentiation of xz square, that would be z square. Did you understand this point? I need to partially differentiate this function with respect to x. So here I would see y is constant, 2xy, this will be 0, z square is constant, so z square only. I cap plus partial differentiation of this function with respect to y. So what that would be, sir, x square common, partial differentiation of x square common plus 2z, and this would be 0 only. J cap plus partial differentiation with respect to z, this will be 0, 2y will become common plus 2xz, k cap. Is that understandable to you? Again, partial differentiation with respect to x I need to do. So y 2xy, this will be 0, z square. So 2xy plus z square, I cap plus partial differentiation with respect to y. So x square you take common, partial differentiation of y will be 1. Then you take 2z common here, partial differentiation of y will be 1 only. So x square plus 2z, here it will be 0 only because there is no term of y. Plus partial differentiation with respect to z, this will be 0. Partial differentiation with respect to z, that means 2y you will take common, plus here x you will take common, 2z will be the partial differentiation of z square. So 2xz k cap. At what point I am supposed to find out? At the point I am supposed to find out 1, 1, 2. 1, 1, 2. X equals to 1, y equals to 1, and z equals to 2. So this will be 2, 1, 1, z will be 2. So this will become 4 I cap plus 1, 4 j cap, 2, 4 k cap, 6 I cap plus 5 j cap plus 6 k cap. Okay, so 1, 1, 4 plus 2, 6, this is 1, then 2z, 4, 5 I cap, then 2 xz. Yeah, this is the directional derivative. So let's call it vector c. In the direction of a particle instantaneous velocity, in the direction of the velocity of the particle. So this is the particle's position vector. Position vector is given, so I need to find out the velocity. I need to find out the velocity vector. This will be my velocity vector. This will be my velocity vector. So can I find out the velocity vector? Partial differentiation with respect to t. This will become 2 I cap plus 2t j cap plus 2t k cap. At what point? At 1 second. At t equals to 1 second. So at t equals to 1 second, what will be the velocity vector you will be getting? At t equals to 1 second, the velocity vector, at t equals to 1 second, the velocity vector that we are getting is 2 I cap plus 2 j cap plus 2 k cap. So what will be the unit vector? That would be 2 I cap plus 2 j cap plus 2 k cap divided by under root 2 square plus 2 square plus 2 square. That would be 2 under root 3. So this is coming out to be I cap plus j cap plus k cap divided by under root 3. And isn't it your a cap only? Look what they are saying, in the direction of a particle's instantaneous velocity at t equals to 1. So you need to find out the velocity vector. Velocity vector you find out. And what is the velocity at t equals to 1? So velocity at t equals to 1 is this. What you need to do? You need to calculate the unit vector. So unit vector in the direction means I need to calculate the unit vector. So unit vector I have calculated, that is coming out to be I cap plus j cap divided by under root 3. What does that mean? That means you need to calculate the what you need to calculate? You need to calculate the directional derivative or component of c in the direction of a. Component of c in the direction of a. Component of c in the direction of a. That's it. So component of c, 6 I cap plus 5 j cap plus 6 k cap. 6 I cap plus 5 j cap plus 6 k cap. I cap plus j cap plus k cap divided by under root 3. 6 plus 5 plus 6, 6 plus 5 plus 6 divided by under root 3. 17 by under root 3 is the answer that we are getting. (9.81). 17 by under root 3 is the answer that we are getting. So the answer is 17 by under root 3. Same kind of question have been asked in GATE examination as well. Okay, so answer is 9.81. These kind of questions are not tough to solve. I hope you will be able to solve these kind of problems very easily. Again and again such questions are asked, but I am pretty sure you will be able to solve. How will you be solving it? Very easily, sir. I need to calculate the gradient of f. Directional derivative they are asking, that means first you calculate the gradient of f, mark it a vector c, then you need to find out the direction, in which direction they are talking about. So here they were talking about AB vector, so not here they are talking about a perpendicular vector, so I find out the perpendicular direction. Here they were talking about AB vector, so I find out the AB vector direction. Here they were talking about a normal vector, so I find out the normal vector direction. Then simply do the dot product. That means you need to find out the components, so simply do the dot product. That's it. Simply do the dot product. That's it. Job done. Okay. Directional derivative, again the same thing. Directional derivative of f at 1, 2. Now in the direction which is making an angle of 30 degree with positive x-axis, you need to find out the vector. You need to find out the unit vector which is making an angle of 30 degree with x-axis. Unit vector which is I need to find out unit vector. What is the meaning of unit vector? Unit vector means it will be having a magnitude of 1. Unit vector which is making an angle of 30 degree with x-axis. Unit vector making an angle of 30 degree angle with x-axis. So this is your x, this is your y. So what will be your a cap? What do you think? Sir, I need to find out this vector. No, so what I can do? I can take its two component. I can take the two components. So one component will be 1 cos theta. 1 cos theta. The other component would be, let's just say this is 60 degree, no? So this will be 1. You can write down 1 sin 30. Basically, you can either write down 1 sin 30. Sir, this will be 1 cos 30 and this will be, sir, 1 sin 30. 1, it will be very tough to write down. So here, or it will be, sir, 1 sin 30 degree. This will be 1 sin 30 and, sir, this will be 1 cos 30. You can write down 1 sin 30 or you write down cos 60, right? Because what will be this angle? What will be this angle? This angle will be 60 degree only, no? This angle will be 60 degree only. So component will be 1 cos 60. So one component is cos 30 degree I cap and cos 60 degree j cap. Okay. So what is your a vector? That is cos 30. What that would be? Under root 3 I cap plus cos 60 is 1/2 j cap. That's it. Okay, you need to find out the unit vector which is making an angle of 30 degree with x-axis. That means it will make 60 degree with y-axis. So on y-axis, what is the component? Cos 60, that is 1/2, and on x-axis, what is the component? That is under root 3/2. Understandable? Okay, so this is your a cap. A cap you have find out directional derivative at this point. So first of all, you need to calculate a gradient of f. So partial differentiation of this function with respect to x. So 2x plus with respect to x, you need to partially differentiate. So y will be treated as common. Plus partial differentiation of this function with respect to y. With respect to y. Then partial differentiation with respect to z, that would be 0 only. With respect to x would be 2x plus y I cap, plus with respect to y would be x plus 4y j cap. Now at what point? At 1, 2. 4 I cap plus 9 j cap. 4 I cap plus 9 j cap. Yes. Okay. So this is your C vector. What you are supposed to find out? C vector dot A vector. Component of vector C in the direction of A. So 4 I cap plus 9 j cap dot under root 3/2 I cap plus 1/2 j cap. So what is the answer you are getting? 2 under root 3 plus 4.5. 4 I cap plus under root 3/2, that would be 2 under root 3 plus 9 into 1/2, 4.5. So 2 under root 3 plus 4.5. 7.96. 2 under root 3 plus 4.5, or you can say 7.96. So answer is 7.96 is the answer. Okay, so that's the answer. So in that manner, we need to solve the problems. Let me take some break and then we will solve other question. This question you solve. Like here also a vector you need to find out. But this time what we are doing, we are making an angle of 60 degree with x-axis, 60 degree with y-axis and 45 degree with z-axis. So this time what will be your a vector? Look, it was making 30 degree with x-axis and 60 degree with like a unit vector making an angle of alpha with x-axis and beta with y-axis. What is the answer we have got here? What was the unit vector? Sir, the unit vector came out to be cos alpha I cap, cos 30 I cap, it was cos 30 I cap, cos 30 I cap under root 3 by 2 plus cos beta j cap, cos 60 j cap, right? So similarly, if the unit vector making an angle of alpha with x-axis, alpha with x-axis, beta with y-axis, beta with y-axis, and gamma with z-axis. So what will be the unit vector? So that would be cos alpha I cap plus cos beta j cap plus cos gamma k cap, right? Is that clear to you? Here it was making 0 degree angle, no? In the previous question, it was making 0 degree angle with the y-axis. 0 or 90 degree angle with the y-axis, no? This particular line is making 90 degree angle with the y-axis because it is in the xy plane. So here value of gamma was 90 degree. So what is cos 90? That is 0. So what was the answer you were getting? Cos alpha plus cos beta. So answer was cos 30 plus cos 60 because it was making 90 degree angle, no? With z-axis it is making 90 degree angle. The line is in this plane and this is your z-axis. So the line is here and this is your z-axis. So angle is 90 degree, right? Perpendicular angle is 90 degree. So cos 90 is 0. So similarly here, if you need to find out a vector, what that would be? 60 degree with x-axis plus 60 degree with y-axis plus 45 degree with z-axis. So what is cos 60? 1 by 2 I cap plus 1 by 2 j cap plus 1 by under root 2 k cap. This will be your vector A. Now again directional derivative at this point, what does that mean? You need to find out the gradient of f. So gradient of f means 2x I cap plus 4y j cap plus 6z k cap. Gradient of f at point 1 comma minus 1 comma 2. So 2 I cap minus 4 j cap plus 12 k cap. Right? Now this will be our vector C. So what you are supposed to find out? Component of vector C in the direction of A. Component of vector C in the direction of A. 2 I cap minus 4 j cap plus 12 k cap dot product with 1 by 2 I cap plus 1 by 2 j cap plus 1 by under root 2 k cap. So 2 into 1 by 2 will be 1, minus 4 multiply with 2 minus 2 plus 12 divided by under root 2 would become 6 under root 2. Okay, so answer is 6 under root 2 minus 1. I guess this answer was written 6 under root 2 minus 1. 6 under root 2 minus 1. This is the answer, or you can solve it. Answer is 7.48. The answer you are getting is 7.48 is the answer we are getting. Okay, so this is how you can solve it. 6 under root 2 minus 1 can also be mentioned, and this is how also you can solve it. Understandable? Next question you try solving on your own. Okay, very simple. In the direction parallel to, at this point in direction parallel to point, very straightforward. This we have already solved. Okay, very straightforward. This should be solved by you. If you are not able to solve it, then that means there is no meaning of this lecture. I am not teaching, either I am not teaching good or you are not studying in a good manner. You need to solve this question correctly. You need to solve. Next, this you can try. This is the finest question. Okay, this is one of the finest question of this lecture. So this you can try. Here good enough thinking will be used, and then this question you can solve. And after that as well, there are 2-3 questions. So we will see that. Okay, but they are in the next slide. So that's why I will have to change the slide. So yeah, you try solving this question now. This is your target. Should be solved. This should be solved. Okay. So let me take a break and then I will come back. Yeah, welcome back. So did you try this question? What we need to find out? Directional derivative of xyz at point 1 comma 2 comma 1. That means first I need to find out the gradient at 1 comma 2 comma 1. So that I will find out. So gradient of f, partial differentiation with respect to x, that will be 2xy. Partial differentiation with, I guess, the same function we have taken. No, it is not taken. Yeah. So partial differentiation with respect to x will be 2xy, and here with respect to x it will be z only, I cap, plus partial differentiation with respect to y. So x square will come common, plus z k cap, and then partial differentiation with respect to z. So y will come common, plus x k cap, 1 to 1. So directional derivative at 1 comma 2 comma 1. So that will be 4 plus 1 I cap plus 1 plus 1 k cap plus 1 plus 2, अरे यार ये j cap है भाई, k cap. Okay, so what is the answer? 5 I cap plus 2 j cap plus 3 k cap. This we will call vector C. Okay, so partial differentiation with respect to x is coming out to be 2xy plus z. Partial differentiation with respect to y is coming out to be x square plus z. Partial differentiation with respect to z is coming out to be y plus x. 1 to 1. So here 1 2 4 1 5. Here 1 plus 1 2 and 2 plus 1 3. Yeah, this is the answer. Now you need to find out the direction parallel to the line joining AB. So what is the vector? This time I will call the vector as p cap. So what I am finding out? I am finding out p vector. So vector p would be 3 minus 2, 5 minus 2, that will be 3 I cap plus 2 j cap plus k cap, right? 3 2 1. Yeah. Now the confusion would be that, sir, where it is said that you need to take p vector only. What if I would have taken the vector to be in the direction of b? What if, sir, I would have taken 2 minus 5, that means minus 3 I cap minus 2 j cap and minus k cap. This also I could have taken, no? Because it is just written that parallel to the line joining AB. So nowhere it is mentioned that you need to take this vector or this vector. Nowhere it is mentioned. So usually the point is that you take any vector, but the answer of directional derivative is always given positive. Are you able to understand this point? No matter whichever the direction you take, you solve the question. Now what you need to do? This is your p vector. No, I need to find out. This is your p vector. I need to find out p cap. Right? So I will find out p cap. Then eventually what I will do? Vector C dot product with p cap. So whatever the answer that you get, answer should be coming positive. You need to take the positive answer. That's it. So if I would have taken minus 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 here, then answer would come out to be negative. So if answer is coming out to be negative, then you take its mode. Are you able to answer this point? Let us say answer came out to be minus 5. If I would have taken here minus 3 minus 2 minus k, then let us say answer came out to be minus 5. Take its mode. So answer will be plus 5. So unless options are mentioned, always take the answer to be positive only when it is about directional derivative. Okay. Although both of the answer are possible, because here nothing is mentioned, line AB joining is mentioned. You could have taken the vector in this direction or in this direction as well. Nothing is mentioned in the question. But what we will do, if it is coming in NETs, unless the options are mentioned, if it is coming in numerical answer type, we will always take the positive answer. This is the point I wanted to tell with respect to this question. So 3 I cap plus 2 j cap plus k cap divided by under root 3 square plus 4 square, 3 square plus 2 square plus 1. What that would be? 9 plus 4 plus 1, that would be under root 50. Right? So C vector dot p cap. So 5 into 3 15 plus 4 plus 3 divided by under root 15. So what is the answer? 22 by under root 15. 22 by under root 50. Under root 14. अरे भाई ये क्या हो गया? हाँ 14 सॉरी. 22 by under root 14 is the answer. Okay, so minus answer could also be possible, but we will always take the mode if it is coming in numerical answer type. Okay, next question. This is a good question. You try doing it on your own. Have you tried it? What we need to do, maximum value of directional derivative at point 1 comma 1 is 18. Maximum value of directional derivative at this point is 18. So what you can find out from this? Maximum value of directional derivative. What is the maximum value of directional derivative? Sir, maximum value of directional derivative is nothing but maximum value of directional derivative is nothing but the magnitude of gradient. Magnitude of gradient is nothing but the maximum value of directional derivative. Why is that so, sir? We have solved a question. The second question that we solved was this only, that you need to find out the maximum value of directional derivative at 1 comma 1 comma minus 1. That means you need to move in the direction where there is a maximum change. So I will move in the direction of gradient only, right? And how much change would be there? That is known as maximum value of directional derivative. That means magnitude of gradient is the maximum value of a directional derivative. Value of directional derivative. And it will happen, and in which direction it will happen? It will happen in the direction of, it will happen in which direction? It will happen in the direction of, in the direction of what? In the direction of gradient of f only, or you can call it in the direction of gradient of f cap. Like basically, what is the maximum value of a directional derivative, that you can find out, and in which direction it will take place? It will take place in the direction of a gradient of f only. That means they are asking that in which direction you should move such that you get the maximum value, or such that you get the maximum change. So I should move in the direction of gradient only. So my first question target is that I find out a gradient of f. What is my gradient of f? So partial differentiation with respect to x, what I will get? Py plus rz I cap. Partial differentiation with respect to y. Partial differentiation with respect to y. Partial differentiation with respect to y. Partial differentiation with respect to z. At the point 1 comma 1. 1 comma 1 comma 1. So I am getting p plus r I cap plus p plus q j cap plus q plus r k cap. This is the directional derivative I am getting. What is the maximum value of directional derivative? What is the maximum value of directional derivative? Sir, maximum value of directional derivative is equal to the gradient of is equal to the magnitude of gradient, and that is given as 18. And what is the magnitude of gradient? What is the magnitude of gradient? The magnitude of gradient is nothing but under root p plus r whole square plus p plus q whole square plus q plus r whole square. Is that clear? Is this point clear? That, sir, from here the maximum value of directional derivative is 18. That means it is simply representing the magnitude of gradient. Now what they are saying? It is attained in the direction parallel to the line, this particular line. That means you are getting the maximum value of directional derivative. It is happening, it will be attained, or it is attained in the direction of this line, in the direction parallel to this line. So let's just say this particular line is given, this particular line is given, this particular line is there. I don't know what is this point, I don't know what is this point. I know the equation of this line. I know the equation of this line. So this line will be parallel to what? So this line will be parallel to a vector which is nothing but this particular vector I cap plus 2j cap plus 2k cap. Say yes or no? This line will be parallel to the vector I cap plus 2j cap plus 2k cap. Say yes or no? What does that mean? That means they are saying that maximum value of directional derivative is attained in the direction of vector I cap plus 2j cap plus 2k cap. Say yes or no. I cap plus 2j cap plus 2k cap. And what you are saying, this is what question is saying. And what you say, I say that maximum value of directional derivative is attained in the direction of gradient of f. What do I say? Maximum value of directional derivative is attained. The same line I will copy. In the direction of gradient of f. In the direction of gradient of f, or I can say del f cap. So what do you understand? What do you understand by the direction of a vector? Direction of a vector. Direction of a vector would be I cap plus 2j cap plus 2k cap divided by under root 1 square plus 2 square plus 2 square. That would be equals to gradient of f direction. Say yes or no. Did you understand this equation or not? Absolutely, sir. Clearly understandable. The maximum value of a directional derivative will occur in the direction of gradient. And they are saying that it is occurring in the direction parallel to this line, and this line will be in the direction of I cap plus 2j cap plus 2k cap. Say yes or no. Why it will be like so? That we have already understood in the basics, right? So there you go. This is the scenario now. Can I find out the direction of gradient of f? Absolutely, sir. That would be nothing but I just need to divide this particular value. I just need to divide this particular value by its, this particular value I need to divide by what? I need to divide this particular value by its magnitude. So this is your divergence of f, right? This is the vector. What you need? You need the direction, no? So since you need the direction, what you will do? You will simply divide by the magnitude. This is the magnitude is there. So you will simply divide by the magnitude. That's it. And both are equal. Now you know one thing. What is the value of this particular scenario? What is the value of this particular scenario? This particular scenario is 18, which is given. This is 18. So now what do you get? That sir, under root 1 plus 4 will be 3 only. So I cap plus 2j cap plus 2k cap divided by 3 equals to p plus r I cap, p plus r I cap plus p plus q j cap, p plus q j cap plus q plus r k cap, q plus r k cap divided by this value is 18. So can I compare I cap components? Like basically this 18 could be written as divided by 18 everywhere, no? Divided by 18 everywhere it could be written, no? Divided by 18, divided by 18, divided by 18. And then this divided by 3 could be written here as well, divided by 3 could be written here as well, divided by 3 could be written here as well. 1 by 3 equals to p plus r by 18. So what is the value you are getting? P plus r equals to 6. From here, p plus q by 18 is coming out to be 2 by 3. So p plus q is coming out to be 12. And q plus r by 18 is coming out to be 2 by 3. So q plus r is coming out to be 12. Right? So from here, p equals to r we are getting. So p equals to r equals to 3 and q equals to 9. So p equals to 3, q equals to 9 and r equals to 3. There you go. This is the answer that we are getting. Is that clear to you? 393. This is the answer. 393. So did you understand how to solve these kind of problems? A very good question could be asked in the future examination. Maximum value of directional derivative would occur in the direction of gradient only. That's the bottom line. Rest everything is done. So what is the maximum value of directional derivative? That will be magnitude of the gradient, and where it will occur? It will occur in the direction of a gradient only. So both of the things, using both of the things, we got the answer. Absolutely clear, sir. Completely understandable. Let's go to the next question. This is again very important question. Again, I would say important question. I don't know how many times this kind of question have been asked. N number of time it has been asked. So in the examination, what they can say, they might not even give this particular thing. They will only write down that R vector is a position vector. That's it. And they will directly ask you what is gradient of R. What is R here? R is the magnitude of a position vector. So in the examination, what they would ask, they would directly give that position vector is R vector. Find out del R. So you will have to understand that, sir, this R will be the magnitude of this, no? Because they are asking the gradient. And if they are asking the gradient, what does that mean? It has to be a scalar. That means it has to be the magnitude only. So what they would give, that R is a position vector. That means it is xi cap plus yj cap plus zk cap. You need to find out its magnitude. That is given as R, which will be under root x square plus y square plus z square. What you are supposed to find out? Gradient of R. That means, sorry, this is not the dot product. I should not be putting dot product here. I can simply put the bracket. Gradient of R you are supposed to find out. What does that mean? So del y del x I cap plus del y del, basically del by del x. This R is the function of x comma y comma z now, right? R is the function of x comma y comma z. So I can write down del r by del x I cap del r by del y j cap plus del r by del z k cap. So let's calculate del r by del x first. What I am calculating? Del r by del x under root x square plus y square plus z square. What you get? 1 by 2 under root x square plus y square plus z square. And partially differentiation with respect to x, so here you will get 2x. Simple partial differentiation it is. I hope you know the answer. So what is the answer you are getting? Sir, x upon under root x square plus y square plus z square. Right? So what you are getting? This is the scenario that you are getting for del r by del x. Can you let me know what will be the answer of del r by del y? So it will be y upon under root x square plus y square plus z square. What will be the answer of del r by del z? So it will be z upon under root x square plus y square plus z square. So what you are getting eventually, you are getting gradient of R you are getting as, sir, x upon under root x square plus y square plus z square. This could be written as x by R. Say yes or no? X by R, what is the value of R? R is under root x square plus y square plus z square. So x by R I cap plus y by R j cap plus z by R k cap. So what I can do? Divided by R I can take common. So it will become x I cap plus y j cap plus z k cap divided by R. Now what is this upper thing? That is R vector divided by R. What you are getting? R cap. So what is the answer you have got? Del R is coming out to be nothing but R cap. There you go. This is the answer. Where R is not a vector, R is the magnitude of vector R, which is under root x square plus y square plus z square. In the examination, they will only mention position vector. They will not even mention this. So R is the magnitude, which is under root x square plus y square plus z square. So when you solved it, this is what we have got. Answer is R cap. Now this L and R, you can try doing it on your own. Let's do del FR. Okay. What we need to do? Del FR we need to calculate. Any function of R. That means it is nothing but del f of under root x square plus y square plus z square. This is what we are supposed to calculate. Is that clear to you? You need to find out the gradient of f under root x square plus y square plus z square. Is that understandable or not? This is what we are supposed to calculate. Right? So what that would be equivalent to? That would be equivalent to del by del x, this function, which is f of r I cap, plus del by del y f of r j cap, plus del by del z f of r k cap. So let's keep it here but let's try finding out del by del x f of r. What is that? Del by del x f of, what is the value of r? Under root x square plus y square plus z square. Can you partially differentiate it? Can you think of it? Can you think of the partial differentiation of this? Let's just say I want you to partially differentiate ln x square. How will you differentiate? Ln x square plus y. How will you differentiate? Sir, first you will differentiate the ln function. That will give you 1 upon x square plus y, and then you will differentiate whatever that is inside. What it will give you? 2x. So similarly, what I will do? First, I will differentiate this function. What it will give me? F dash, whatever that is inside. And then what I will do? Then I will differentiate this particular scenario, whatever that is inside. Did you understand this point or not? How I was differentiating ln x square plus y. So first I differentiate this ln, which will give me 1 by x square plus y, and then I differentiated x square plus y. Then I partially differentiated x square plus y. So similar thing I have written. First I have differentiated this function f of r, which will give me f dash this. Then I differentiated whatever that is inside with respect to x. Say yes or no. So what this will give me? Del by del x under root x square plus r square, x square plus y square plus z square. This we have already seen. This will give us something like x by r. What it is giving us? X by r. This particular differentiation is giving us x by r. This we have already seen. So it is giving us x by r. So f dash r, this is r only, no? This is r only. So f dash r dot x by r. This is what I am getting. So this is the answer of del by del x fr. Del by del x fr is giving me f dash r dot x by r. So what do you think? What other guys will give me? This is what I am supposed to calculate. The answer of del fr by del x is coming out to be f dash r dot x by r. So x into f dash r divided by r I cap plus what this will give me? Del fr by del y. It will give me y dot f dash r divided by r. Y dot f dash r divided by r. It is not a dot product, it is a multiplication. It is pretty obvious. You are not getting confused with this. Z f dash r divided by r k cap. Say yes or no. So what you are getting? Sir, f dash r divided by r I can take common. F dash r divided by r I can take common. F dash r divided by r I can take common. X I cap plus y j cap plus z k cap. So f dash r divided by r, and this is r vector. Now r vector divided by r, what it will give us? R cap. So what you are getting? Gradient of fr is coming out to be f dash r, then simply add r cap. You need to remember it. If I ask you what is the differentiation of fx, what answer you will give? Sir, f dash x. So similarly, it is like this only. If I ask you what is the gradient of fr, you are giving the answer f dash r. But since you know that, sir, gradient I am calculating, it has to be a vector quantity. So just add up r cap as well. As a direction will be r cap. That's it. So if I ask you what is del ln r, what will be your answer? So differentiation of ln r, which will be 1 by r cap. That's it. This will be the answer. Now next, if I ask you what will be the gradient of ln cos r? Ln cos r. So sir, differentiation of ln cos r, what that would be? Sir, 1 by cos r. I need to differentiate ln cos r with respect to r. Ln cos r with respect to r I need to differentiate. So ln cos r I am differentiating with respect to r. I am differentiating with respect to r. So what answer I will be getting? Sir, 1 by cos r, differentiation of cos r will be minus sin r. So this is what I will be getting, right? Differentiate this function with respect to r, then only you will get no f dash r. So differentiate this function with respect to r. What will be the answer you will be getting? 1 by cos r, then differentiation of cos r will be minus sin r. First you will differentiate ln, then you will differentiate this function. So 1 by cos r, then differentiation of this cos r will be minus sin r, and then simply add r cap. So what is the answer you are getting? Minus tan r cap, right? Minus tan r cap. Next, gradient of cos ln r. Let us say cos ln r. This I am supposed to calculate. So first you need to differentiate cos. What is the differentiation of cos? The differentiation of cos is minus sign ln r. Then you need to differentiate ln r. What is the differentiation of ln r? That will be 1 by r, and then r cap. Okay, so this would be the answer mentioned. This could be the answer mentioned, or what could be the answer mentioned? So the answer mentioned could be r cap could be written as r vector divided by r, so it will become r square. So this could also be the answer mentioned. Here as well, the answer could be mentioned is 1 by r. R vector could be written as, so r cap could be written as r vector divided by magnitude of r, which is r only. So answer mentioned could be 1 by r square r cap, sorry, 1 by r square r vector, or you can say r to the power minus 2 r vector. This answer could be mentioned. I hope you would have understood. R cap could be written as r vector divided by the magnitude of r. So it will become 1 by r square r vector. So it will become r to the power minus 2 r vector. Understandable? Or it could be written, this answer could also be written minus r to the power minus 2 sin ln r vector. So this will look a bit surprising type of answer, but it is simple only. Minus r to the power minus 2 sin ln r cap. R vector, not r cap, r vector. So this is the answer. Understandable? So 2-3 more questions are there on gradient, but as of now I need to change the slide. Okay, because in the next slide I wrote down those questions. So what I will do is that I will change the slide. 2-3 more questions are there on gradient. Then we will start divergence. Okay, divergence and curl. So that we can do in the next lecture. So in this lecture only, what I will do as of now, I will pause the video, change the slide, and we will solve those 2-3 questions, and our job would be done. Okay, and then we can start divergence and curl in the next lecture. So I will change the slide now. I will pause the video and I will change the slide. Okay, yeah, thank you. Yeah, welcome back. So a few more questions we need to solve, and then we will be done. Okay, we will be done with the gradient. So this question again, gate to IQ only. A vector is given, you need to find out the normal to the plane defined by W transpose X. Okay, W transpose X equals to 1. Is this the equation of a plane? Absolutely. Why is that so? Because what will be W transpose? So W transpose will be nothing but 1, 2, 3. W is 1, 2, 3 transpose. So W transpose will be transpose of transpose. Transpose means the same matrix. So W transpose will be 1, 2, 3, and what is X? X would be a vector which is xi cap plus yj cap plus zk cap, and that would be equals to 1. This is equals to 1. So what you will get here? X plus 2y plus 3z equals to 1. What you are supposed to find out? You are supposed to find out the vector normal to the plane. Normal you are supposed to find out. So what will be the normal? For finding out the normal, so I need to define a function phi, which will be x plus 2y plus 3z minus 1, and then I need to calculate its gradient. So that will be partial differentiation with respect to x, partial differentiation with respect to y, and partial differentiation with respect to z. This will be the answer. Other answers are also possible. 2 answers are possible. One of the answer is this. Other answer will be possible will be, sir, if an cap is one of the vector, then minus an cap will also be one of the vector. Here they are not writing down the unit vector. Here just writing down a vector which is normal. Okay, a vector which is perpendicular. So the unit vector is not necessary. So here they are not writing down the unit vector. They are writing down directly the vector only. So possible answer could be 1, 2, 3. 1, 2, 3 is one of the possible answer, or minus 1, minus 2, minus 3 also could be the answer. 1, 2, 3 is mentioned. This is the answer. Understandable? Next question. A quadratic function of 2 variables is given. The magnitude of the maximum rate of change at the point 1, 1. Magnitude of the maximum rate of change at 1, 1. What does it represent? Magnitude of maximum rate of change at 1, 1. Gradient. It will not click in the examination hall if your concept of gradient is not clear. If you don't know the physical significance. I told you, no, you are at 1, 1. That means you need to move in the direction of I cap plus j cap by under 2 to get the maximum change. So it is the maximum rate of change at 1, 1, and this is the direction. Right? So you need to find out the magnitude of maximum rate of change of the function at 1, 1. So what you are supposed to find out? You are supposed to find out that what they are asking. You are supposed to find out that magnitude of gradient of f, magnitude of gradient of f at 1, 1. So this time variable are x1 and x2. Previously we used to define our gradient of f as del by del x f I cap plus del by del f y j cap del by del z del f by del z k cap. But now how we will define? Now how we will define? There are two variables x1 and x2. So del y del x f I cap, or you can write down direction of ax1 cap, direction of x1, right? Here it is the direction of x, direction of y, direction of z. So direction of x1 del f by del x2, direction of x2, direction of x2. This is how you can define it. So your gradient of f is coming out to be, first you need to partially differentiate with respect to x1. So partial differentiation with respect to x1. So differentiation of x1 square will be 2x1 plus this will be 0, x2 will be coming common, plus 3 a x1 cap, plus this will be 4x2, this will be 0, 4x2 you will get here, plus x2 will come common, sorry, x1 will come common, partial differentiation of x2 will be 1, then 3 a x2 cap at point 1 comma 1. So you need to put 1 comma 1. So what you will be getting, 6 ax1 cap eight ax2 cap, right? So what will be the gradient of f? What will be the magnitude of gradient of f? They are asking about the magnitude, right? They are asking that if you are at 1 comma 1, then what is the magnitude of maximum rate of change? So what is the magnitude of maximum rate of change? So magnitude will be, sir, 6 square plus 8 square, 6 square plus 8 square, 6 square plus 8 square. So answer will be 10, and this will become 100. So answer will be 10. This is the answer that you will be getting. Understandable? Clear? This is the answer we have. Let's go to the next one. Yeah, now this kind of question we need to solve. The two functions are given, phi of x comma y comma z equals to 4, phi of, and xi of x comma y comma z equals to 5. Then you need to find out the angle between two planes. Angle between two planes. So our next topic is angle between two planes. But do you remember angle between two vectors? What is the angle between two vectors? So this vector A, vector B. What is the angle between vector A and vector B? So angle between vector A and vector B is theta. So this is the angle between vector A and vector B. What will be the answer? The angle between vector A and vector B could be given as, sir, A dot B equals to magnitude of A, magnitude of vector A multiply with the magnitude of vector B cos theta. So what you get? Sir, cos theta would be equals to A vector dot B vector divided by magnitude of A, magnitude of B. So can I write it down in this manner? A vector divided by magnitude of A dot B vector divided by magnitude of B. So this could be written as A cap dot B cap. So cos of angle between two vectors is the dot product of their unit vectors, right? Dot product of their unit vectors. Understandable? So this is the angle between two vectors. Take a vector A, find out its unit vector. Take vector B, find out its unit vector. Do the dot product, you will get the cos of that. That's it. So what about the angle between two planes? So angle between two planes is always equal to the angle between two planes is always is equal to the angle between their perpendicular surface area vector. Perpendicular surface area vector. That means what you will do is that you will find out the surface area vector for the planes, and then you will simply calculate the angle between them. That's it. Okay. But the task is that, let's just say this is one plane and this is the other plane. They are cutting each other. Now two angles they will make, no? Although they will make four angles, right? One angle will be this. I hope you are able to understand. This is the line I have taken on this plane. Let's call this as plane 1. Let's call this as plane 1, and let's call this as plane 2. So this is the line I have taken on plane 1. Next line I am taking on plane 2. So this is one of the angle. This is one of the angle. This angle is theta. And another angle is possible, which will be 180 minus theta. So what I mean to say is that this is the another angle which is possible. This angle is theta. angle between planes, this angle is theta and the another angle is 180 minus theta. So two angles are possible. Okay, so always whenever they talk about angle between planes, let's say that is theta, so the value of theta will be between 0 to 180 degree only. Why it is so? If this angle is theta, then what you do is that you take this line backward. So what will be this angle theta? What will be this angle? This angle will also be theta only, no? I hope you are able to understand. Two planes are there. What is this angle? This angle is theta. So what will be the other angle? Which will be 180 minus theta. So what will be the angle downward? That will also become 180 minus theta. And what will be this angle? This angle will be theta only. I hope with the geometry you are able to understand. Here they are completely making angle of 180 degree. This is the complete angle of 180 degree, right? So this angle is theta. This angle is 180 degree minus theta. We start from here. This angle is theta. This angle is theta. So this angle will be 180 minus theta. This angle will be 180 degree minus theta. So what will be this angle? This angle will be theta only. Then what will be this angle? This angle will also be 180 degree minus theta. I hope you are able to see these lines, right? So this angle theta will be equivalent to the angle between the perpendicular vectors, or angle between the surface area vector, or angle between the normal surface area vector. Understandable, sir? Why is that so? So you can try thinking of the geometry. Like this is my plane. This is my plane, right? So I am taking the perpendicular vector. This is my plane 1. I am talking about plane 1. So perpendicular vector. So perpendicular vector will be somewhat like this, no? Here I am showing perpendicular vector will be somewhat like this. Perpendicular to this plane. Perpendicular to this plane. It will be somewhat like this. So let's make it somewhere here, right? And then I am making perpendicular vector to this plane, which will be somewhat like this. Perpendicular vector to this plane, which will be somewhat like this. Say yes or no, right? Do you understand this point? Are you able to understand or not? Perpendicular vector and perpendicular vector upper side I have made. Is that clear? Now what do I do is that now if I make this line, this line I have made, this yellow line I have made, right? So yellow line and then the perpendicular vector, yellow line and then the perpendicular vector, this angle is 90 degree, no? And if I make this green line as well, if I make this green line as well, so angle between these two lines is the angle between the planes, no? This angle is theta, no? This angle is theta. Are you able to understand this point? This green line I have made, this yellow line I have made, and then I have made these perpendicular vectors. This is the perpendicular vector of P1 and this is the perpendicular vector of P2. Now if this angle is theta, what is this angle then? What is this angle? This angle is 90 minus theta. And what will be this angle? The angle between this plane. I know that this whole angle is 90 degree, no? Because this is the perpendicular vector of the plane and this is the parallel vector. Can I say this is the parallel vector of P1? This green is the parallel vector of P1 and this is the perpendicular vector. So this whole angle is 90 degree. So what will be this angle? This angle will be 90 minus theta. Say yes or no. Are you able to answer this point? This whole angle is 90 degree. This whole angle is also 90 degree. And this angle is theta. So from here, these angles I have made. Now, if I am finding out the angle between these perpendicular vectors, then what is the angle I am getting? 180 minus theta, right? The total angle that I am getting is 180 minus theta. This total angle between the perpendicular vectors, angle between perpendicular vectors, that I am getting is, sir, 90 minus theta plus 90 minus theta, that will come out to be 180 minus theta, because it will be 180 minus 2 theta plus theta, so answer is 180 minus theta. So yes, 180 minus theta is one of the answer. So if you talk about the angle between two planes, then two answers would be there, no? One answer would be theta and other would be 180 degree minus theta as well. Two answers would be there. I should not write down equal. I would say that angle between two planes would be, one answer would be theta, other answer would be 180 degree minus theta. Two answers are possible. Okay, so if I have got the answer to be 180 minus theta, then what I would do, I would subtract it from 180 only. So what is the answer I'm getting? I'm getting the answer to be theta. Let's just say I calculated the value and I got to know that value is coming out to be 73 degree. Then other answer is also possible. No, that would be 180 degree minus 73. That's it. So either my answer is 180 degree minus theta or answer is theta. I only need to do one thing, that you need to subtract it from 180 degree. Your job would be done. So what I need to do is that I need to find out the perpendicular vectors and simply find the angle between them, and whatever the answer I get, I subtract that answer from 180, I would get two answers. Solve the questions. This is the question that is given. Surface is given. What is the equation of surface? X square y plus y z square equals to 4. This is first surface, and other surface is x y square plus x square z equals to 5. Two surfaces are given. What I would do is that I would make a function phi x square y square z minus 4. I will calculate its gradient. Gradient is coming out to be partial differentiation with respect to x plus partial differentiation with respect to y plus partial differentiation with respect to z. Right? This is what I am getting. Now I need to put the point 1, 2, 1. 1, 2, 1. So 1, 2, 1. So 2 into 2 will be 4. 1, 1 will be 2 and 4 k cap. This is one we are getting. Let's call it phi 1. So this is the gradient you are getting. And what is the other gradient you will get? Your phi 2 would be x y square plus x square z minus 5. Gradient of phi 2 would be y square plus 2xz I cap plus partial differentiation with respect to y, that would be 2xy j cap plus partial differentiation with respect to z, that would be x square k cap. So you need to put the point 1, 2, 1. So 2 will be 4, 6 I cap plus, do the calculation with patience. There is nothing but the calculation only, plus x square, that would be k cap. That's it. So you need to find out the angle between these two guys. You need to find out the angle between these two guys. So what I need to do, if I need to find out the angle, what I would do? I would calculate the unit vector. I would calculate the unit vector. So what is the unit vector you are getting? 4 I cap plus 2 j cap plus 4 k cap divided by under root 4 square is 16 plus 4 plus 16. So divided by 6 you will be getting 6. So 2 by 3 I cap plus 1 by 3 j cap plus okay, it is under root 34. It is under root 34. Okay. अरे यार 34 कहाँ है, 36 ही तो है. Brain fade. 36. So 4 by 6 is 2 by 3. 2 by 6 is 1 by 3. And 4 by 6 is 2 by 3. Okay, and here what will be the scenario? 6 I cap plus 4 j cap plus k cap divided by 36 plus 40, 41. 36 plus 4, 40 plus 1, 41. So this is the scenario. So what you need to find out? You need to find out the angle between them. So that will be equal to cos theta would be equal to dot product of both of them. 2 by 3 I cap plus 1 by 3 j cap plus 2 by 3 k cap. Dot product we need to do 6 by under root 41. Just a complex calculation, nothing else. Just calculation is complex, otherwise the question is very straightforward. 4 by under root 41. Hopefully I am not messing up the calculation, otherwise I will have to check it again. And 1 by under root 41. This time I don't even have the answer. So 2 by 3 into 6 by under root 41. Let's get started. Two by 3 into 6 by under root 41, 0.624 plus 4 by 3 divided by under root 41, 0.208 plus 2 by 3 divided by under root 41, 0.104. So if we add all of them, plus 0.208 plus 0.624, then take cos inverse. Let me recheck the calculation. Okay, I don't think it is the correct answer that I am getting. Let me recheck the calculation. Yeah, so I saw the mistakes. 36 plus 4. 36 plus 4 I have done here. 36 plus 16 I need to do. No, 4 square will be 16. So 36 plus 16 will be 52 plus 1 will be 53. Okay, so here it will be 53. Here it will be 53. Okay, so when you solve it, what answer you will be getting? We are getting, if I solve it completely, you can do the calculation. 6 into 2, this will become 12 by 3 under root 53, which will be 4 by under root 53. This will become 4 by under root 53, because 2 into 12 by 3, 4 divided by under root 53, plus 4 by 3 under root 53 plus 2 by 3 under root 53. So answer is 6 by under root 53 you are getting, because 4 by 3, 2 by 3 will be 2. So 6 by under root 53, which is cos theta. So cos theta equals to 6 by under root 53. 53 under root 6. So 0.824. And then you take the cos inverse. So 34.49. 34.49. Okay. This is the answer that you are getting. Other answer will also be there. This could be one of the option. Other answer could be, that would be 180 degree minus theta 1. So 180 degree minus 34.49 degree. So minus 180, 145.5. 145.5 degree. So two of the option could be mentioned, but only two answers are possible. Okay, 34.49 and 145.5 degree. These two answers are possible. Solve this question. This is the last question of this lecture, and then we will move to next one. So solve this question. Angle between two planes. This time sir, point is not given. So what? Here, if you find out the gradient, if you make the function phi1, what is the gradient you will get? You will get the gradient which is independent of xyz. That's why they did not even give you the point. Okay, it will be independent of xyz. So what will be the gradient? So that will be 2i cap minus j cap plus 2k cap, and here I cap plus 2j cap minus 2k cap. What you need to do? You need to take the unit vector. That would be 2i cap minus j cap plus 2k cap divided by under root 2 square plus 1 square plus 2 square. That would be divided by 3. And here also unit vector I cap plus 2j cap minus 2k cap divided by 3. Right, this is the scenario. Both are same only. Now what I need to do? I need to calculate the cos theta. Right, what will be cos theta? Dot product of both of them. Cos theta will be dot product of both of them. So 2 by 3 into 1 by 3 will be 2 by 9. 2 by 3 into 1 by 3 will be 2 by 9. Minus 1 by 3 plus 2 by 3 will be minus 2 by 9. 2 by 3 minus 2 by 3 will be minus 4 by 9. Cos theta is minus 4 by 9 you are getting. What is the graph of cos theta? This is the graph of cos theta, right? So it will be somewhere here. Cos theta equals to minus 4 by 9 you are getting. So you can simply put it like it will be somewhat less than 180 degree, but it would be greater than 90 degree. So in the calculator you can put 4 by 9 put the plus minus sign, then put cos inverse. 116.38 it will give you. 116.38. This calculator will give you the answer in the range only. The range of between 0 to pi it will give you. All the answer it will give you between 0 to pi. X equals to 0 to pi. Okay. For sinusoid as well, it will give you all the answers. For sinusoid actually, it will give you the answer between minus pi by 2 to pi by 2. From minus pi by 2 to pi by 2. Let's just say here if I put in this calculator, if I put value of 0.5 plus, I am asking in this calculator, I am asking sine inverse minus 0.5. Let's just say what answer it gives. Yeah, so it is giving you minus 30 degree. That means what is the domain of sine inverse x? That is between minus pi by 2 to plus pi by 2. So it will give you the answer between minus pi by 2 to plus pi by 2 for sinusoid. For cosinusoid, it will give you the answer between 0 to pi. Okay, understandable? So calculator itself is giving me the answer 116.38 degree. So this will be one of the answer. What will be the other answer? So other answer will be simply subtract 180 from it. Sorry, subtract this number from 180. Subtract this from 180. So 116.38 subtract this from 180. So 63.62. 63.62 degree. This is the other answer. That's it. The concept of gradient is completed. Okay. So here we saw the basic meaning of divergence, curl, and not meaning. We saw the formula only for divergence and curl. But for gradient, we have studied everything. We studied the physical significance. We saw the questions as well. We saw the formula as well. Everything we have studied. In the next lecture, we will get started with the divergence. Okay. We will get started with the divergence. Physical significance of divergence we will see. Okay. At a point A. At a point A. Divergence of vector field, the orientation of vector field f is given. So let's just say vector field is f. So you need to find out the meaning of divergence of f at point A, what that would be. So that we need to see. Understandable? So let's meet in the next video. Thank you very much. And this is a new t-shirt of PrepFusion, although it's been roughly around 2 months since we have launched it. But I guess this is the first lecture video in this t-shirt. Okay. Yeah. Thank you.